Uh, Respected Dokne sir, are you here? Hello. Hello.
Hello.
Respected Dokne sir, have you joined the session? Welcome, Dr.
Yes,
Tawfiq
ma'am.
sir.
Yes, good morning.
Very good morning, sir. All the respected dignitaries have joined the session. Now, for the technical session of day 2 on the conference, International Interdisciplinary, based on the theme Material Science and Knowledge Convergence, Recent Advances for Sustainable Development, organized by Musaji Maharaj Mahavidyalaya Darwa. For the technical sessions, we are honored to have Professor Dr. G.R. Dhokne, BOS Chairman in Physics, Sant Gadge Baba, Amravati University, Amravati. For the technical session, I am honored to invite Principal of our college, Professor Dr. Sunil Chakpe. I request sir to please be on the session with us. I request Vice Principal of our college and the convener of this conference, Professor Dr. Prashant Bageshwar, to please grace the session by his presence. I
Hello, madam. I think your mic is mute.
invite Dr. Bhagwat sir to please welcome Principal Professor Dr. Chakwe sir by offering a bouquet. Thank you, sir. I invite Dr. Kushal Davde, Head of Commerce Faculty, to please welcome Professor Dr. Prashant Bageshwar by offering a bouquet. Thank you, respected sir. I invite Dr. Sandeep Burle, Head Department of History, to please welcome convener of the conference, Professor
Good morning and a very warm welcome to all of you. Dear friends, today is the second day of International Interdisciplinary Conference on Material Science, Recent Advances for Sustainable Developments. At this outset, we are with us Principal of our college, Dr. S.B. Chakre sir, convener of this two-day international conference, Dr. Najia Rashidi ma'am, as well as we have with us Dr. Santosh Chatur, who is the head of the arts faculty. Another colleague, Dr. Kushal Davade sir, who is the head of the commerce faculty. Madam Neha Mahurkar, who is doing very well conduction of this program. All my friends, research colleagues, participants, researchers, and my dear students. It gives me an immense pleasure and privilege to introduce the chairperson of first technical session of the day. The chairperson is my very close friend, Dr. Gopal Ramesh Rao Dhokne. He has completed his MSc in physics with digital electronics as a specialization from the Government Institute of Science and Humanities, Amravati, Maharashtra, India in 1993. He has completed PhD in physics in 2009. He is a recognized PhD supervisor and postgraduate PG teacher, and he is actively guiding research on functional material, nonlinear optical material, and polymers. Under his mentorship, numerous scholars have successfully completed their doctoral degrees, while others are currently pursuing their PhD research. Dr. Dhokne sir has published more than 52 research papers in reputed international journals and presented over 40 papers at national, international seminars and conferences. He is an editor of the international reputed journal Multilogic in Science. He has made substantial contributions to the academic literature, serving as both an author and as an editor on more than 7 published books. He is also a reviewer for the numerous reputed international journals, including Journal of Optics, Springer Nature, and Current Applied Physics elsewhere. Currently, he is working as a professor and head Department of Physics at Arts, Commerce and Science College, Chikaldara, Maharashtra, India. In addition to his academic responsibilities, he serves as the chairman of Board of Studies in Physics at Sant Gadge Baba Amravati University, Amravati. He is also a member of the Academic Council of Sant Gadge Baba Amravati University, Amravati. Also a member of Maharashtra State Secondary and Higher Secondary Education Board, Pune. He is also an executive member of the Amravati University Physics Teacher Association, that is OPTA. His contribution extends beyond the academia into the innovations with a UK design patents and an Indian design patent for the technological solutions in the industrial energy and agriculture sector. Dear friends, Dr. Dokne sir is a very renowned person in the university area. Actually, he has a he has a very long CV, but because of time constraint, I stop here. And once again, I welcome the today's speaker, Mohammad Taufik sir, as well as the chairman of the session. Thank you.
Thank you, respected sir, for introducing such a great personality. For today's technical session, we are privileged to welcome our distinguished speaker, Dr. Taufik Ahmad Mujawar, postdoctoral associate at Mazar University, Brno, Czech Republic, who will deliver a talk on sustainable synthetic strategies for bioactive molecules, from design to scalable chemistry. Sir, on the behalf of organizing committee, we warmly welcome you, and I now for the technical session hand over this session to the chairperson, Professor Dr. G.R. Dhukne sir. Over to you, sir.
Madam, thank you. First of all, very good morning to one and all. Mungsaji Maharaj Mahavidyalaya, Darwa District, Yavatmal, Maharashtra, India, organized an international interdisciplinary conference on material science and knowledge convergent.
Hello, sorry
Yes.
to interrupt, sir.
Yeah.
Sir, your volume is very less.
Okay. Now am I audible, ma'am? Hello. Hello.
Okay, sir. Please continue. Thank you.
Okay. Ha. Again, first of all, very good morning to one and all. Mungsaji Maharaj Mahavidyalaya, Darwa District, Yavatmal, Maharashtra, India, organized international interdisciplinary conference on material science and knowledge convergence, recent advances for sustainable development, MSKC 2026. First of all, I would like to express my thanks to the organizing committee who invited me as a chairperson of this technical session. The principal of this college, Dr. Sunil Chakwe sir, my friend, Professor Prashant Bageshwar sir, Vice Principal of this college, Professor Najia Rasidi ma'am, convener of this international event. It's my great honor to introduce the eminent speaker for this technical session, Mr. Dr. Taufik Ahmad Mujawar sir. Sir, welcome to this international event. Taufik Ahmad sir, very good morning and welcome to this international event. Namaskar. I would like to introduce the today's speaker of this technical session, Professor Taufik Ahmed Mujawar sir, the postdoctoral associate.
Sorry to interrupt. Sorry to interrupt, but I'm not a
Yeah.
professor.
Okay.
Sorry.
Okay. Dr. Taufik Ahmed Mujawar sir, thank you. Dr. Taufik Ahmed Mujawar is a creative and solution-oriented synthetic organic chemist with a PhD in organic chemistry from Mazark University, Czech Republic. He has over 10 years of experience spanning academic and industrial research and development field. He is currently a postdoctoral associate in Mazark University, where he designed complex natural products and stable isotope labeled compounds for mechanistic and tracer studies while mentoring undergraduate and postgraduate students. Previously, he contributed significantly to API and industry synthesis at CSIR, IICT, and pharmaceutical research and development laboratories in India, including work of Leclerc and other bioactive molecules. Dr. Mujawar has excellent publication record in high impact international journals, including Journal of American Chemical Society, Journal of Organic Chemistry, Journal of Physical Chemistry A, Chemical Communication, Synthesis, and Tetrahedron Letters. His notable contribution include the development of modular synthetic platform for bilir- bilirubin oxidation products, innovative microelectroflow reactor system for ultra-fast RNA and API synthesis, and practical synthesis route to neurotropic and bioactive compounds. He is also a co-inventor on a US patent related to microelectrolysis reactor for CC coupling and API synthesis. His research has been recognized through award-winning conference presentations, reflecting his strong impact in sustainable synthesis, flow chemistry, and advanced organic methodology. Dr. Mujawar have the various skills in different fields of the research like synthetic chemistry, stable isotope probing, catalysis, flow chemistry, analytical technique, and so on. The Dr. Mujawar have used information because but the lack of time, I would like to finish here the introduction of Dr. Taufik Mujawar sir. Again, I welcome you, and I would like to invite Dr. Mujawar to present their presentation on sustainable synthetic strategies for bioactive molecules from design to scalable chemistry. Dr. Mujawar sir, again, on the behalf of organizing committee, I welcome you, and now you can proceed your presentation. Thank you. Thank you very much.
Thank you. Thank you for the kind introduction. And good morning to everyone. Yes. Right, my yeah, I mean, can you see my presentation? No.
Yes, sir. Presentation is visible.
Okay, thank you. Thank you for kind introduction. So today I will talk about the sustainable synthetic strategies for the bioactive molecules from the design to scalable chemistry. So, so you might just ask why this is matters because the rising demand regarding the rising demand of the bioactive compound across the pharma and agro materials, and we have to make the environmental friendly and economic pressure to traditional synthesis. So that's why our focus was to get to integrate the sustainability and molecular design stage using the develop the synthetic strategies using the atom efficient catalytic and low waste material routes. Plus also include the this could be a safe, cost effective, and it could be from the easy to scale up from the lab to manufacture. So my goal was to get the design and deliver bioactive molecules that potent and practical and environmental responsible. So today I will talk about the briefly about the a platform for the synthesis of oxidation products of the bilirubin, which was published in the Journal of American Chemical Society in 2024. And if time permits, I will talk about the synthesis of monochiol and the API of daclatasphere using the microflow flow reactor. So I'll talk just move towards the bilirubin. So you might heard the word the bilirubin. So our body generates an bilirubin, and this is the daily uh, it's a daily life of our biological process. So you might ask like how our body generates an bilirubin. So you might heard about the red blood cells. So these red blood cells has a particular life cycle, and after completing their life cycle, they are destroyed in the organ like liver and spleen and generates an hemoglobin. The generated hemoglobin further degrades into the heme component and the globin component. The heme components has an globin component has an amino acid, so it's utilized in the body again. The heme component further degrades into the bilirubin, and this process catalyzed by an enzyme called hemoxygenase. The generated bilirubin is rapidly reduced into the bilirubin by bilirubin reductase. The generated bilirubin, which is poorly water soluble. So to get rid of from our body further convert into the conjugates with the glucuronides and get some from the water soluble conjugate bilirubin. So what if this toxic bilirubin from unconjugated bilirubin to conjugate bilirubin was not developed or not partially developed? So how to remove this one? So and this happens sometimes in a newborn case. So you might have heard about this jaundice newborn. So to treat this jaundice, you might have seen this kind of phototherapy to treat the neonatal hyperbilirubinemia patient. So to understand behind this phototherapy, we need to understand the structure of the bilirubin. So if you see the structure of bilirubin, it's not a planar molecule, it's a rigid molecule by uh, crystal photography. Hello. Uh, so due to this forming an
Hi.
economical hydrogen.
Hello, sir. Sorry to interrupt you.
Yeah.
Voice is not so clear.
Just a minute. Let's look into that. Yes, I think it's for me. It's normal here from my side because I cannot speak louder here, so otherwise somebody will complain. So that's a problem.
Organizer. Again, I request to the organizer, please check.
Sir, you can join the session again.
Yes, yes.
Please
Ma'am,
leave
your voice is
and rejoin.
very clear.
Okay, but the problem is that here I cannot speak louder here, so that's why. But I will try to.
Okay,
find
okay, sir.
some.
Okay, okay,
Sure.
sir. You can continue, sir.
Okay,
Okay.
no issues.
Okay. Oh, thank you. So to understand this beyond this phototherapy, we need to understand the structure of the bilirubin. So the bilirubin is not a planar molecule; it's a rigid tile molecule, and due to because this is forming an intramolecular hydrogen bonding. Due to this intramolecular hydrogen bonding, the heteroatoms are not interacting with the water molecule. That's why this bilirubin is poorly water soluble. So when it's exposed to the light, the certain double bond gets isomerized. If you considering like this bond, so it's getting isomerized from Z to E configuration. So due to this isomerization, now the hydrogen bond get disturbed. Now these heteroatoms are interacting with the water molecules, so it's becoming a water soluble isomerized bilirubin. It also further converted into cyclic form called as lumirubin, which is also as a water soluble compound. This is the main principle behind this phototherapy to treat neonatal hyperbilirubinemia patients. It's called as jaundice, neonatal jaundice. So the bilirubin has a strong antioxidant properties, and in oxidative stress, and even in the photooxidation is further degrades, and it further degrades into the monocyclic fragments called as boxes, which was first identified by in 2000 and later in 2018 by Boxy. Bicyclic molecule called as propiondipenes. So which was first described in the 19th century, but was not fully characterized until 2016. And the third, the tricyclic molecule called as biopirines, which was first speculated in 1994, but it was not uh, uh, fully characterized until 1994. So, so to if you see the synthetic point of view, the boxes can be prepared by bilirubin degradation and even by chemical synthesis. Regarding the propiondipenes also can be prepared by bilirubin degradation, and the propandipen B1B2 we reported in 2022 their chemical synthesis. And regarding the biopirines, it was never synthetically prepared; it was just isolated from the urine. So we decided to synthesize this photoxidation products of the bilirubin. You might ask why we needed to synthesize this photoxidation products. So because there are we because these methods was like the bilirubin degradation and the isolation from the urine or blood is are not practical. So we have to develop some synthetic strategy to for this one. So my goal was to give and convenient access to these various oxidation products of the bilirubin for research purpose. So this will solve some fundamental problems like how these bilirubin photoxidation products are formed. So we will know the mechanism of this, how these bilirubin photoxidation products are formed. The second, we will know their biological activity, and or also we will know that is they are toxic or they are beneficial. To answer such kind of questions, we need to rely on this bilirubin degradation and oxidation isolation methods, which are not practical. So that's why we decided to synthesize these oxidation products of the bilirubin. So we did our retrosynthesis analysis, and we identified these three repeating substitution subunits are repeating as indicated in three different colors. So if we considering the lactam code like indicated in the blue and the red color, there are substitution different like the on alpha position and the beta position like in YNL and the propylate subunit. So our idea was to synthesize the pre-functionalized building block and the assemble in such a way that we can synthesize all the bilirubin photooxidation products, including the parent compound like biliverdin and bilirubin. So to move our synthetic strategy, so we decided to first synthesize these pre-functionalized spiral building blocks. So to synthesize this one, so we started from commercially available material like the cheaper ones. So we started from the succinate anhydride and then ethyl acrylate, which was first we prepared the two different nitroacetate intermediate in the 3 to 4 step respectively. And then we did the Barton-Dart reaction using on the turbutyl isonitroacetate and get the desired substituted pyrroles with two different pyroles, which was functionalized using the iridium catalyzed borations, get the desired two functionalized pyrobuilding block. To make the formal substituted parallel building block, we started from this substituted rule. First, we introduced the formal group Wilson reaction, followed by we did the formic acid treatment to create the turbutyl ester, and then we did the copper catalyzed decarbonylation to get this formal substituted petrol. Later, we tried the same reaction condition using the iridium catalyzed borylation, and we unable to get this product. There was no reaction with this iridium catalyzed borylation. So we performed the two-step protocol. So first we did the iodination, followed by palladium catalyzed borylation to get the desired formal substituted parallel building block. To make this another functionalized building block, we decided to make this 6 another functionalized building block. So to make this 6 functionalized build, and you might ask here why we need to synthesize the lactone course, because we have our core is in lactone. So because the lactones we can easily convert into the lactone by ammonite treatment followed by smile acid treatment. So we could form an amide and cyclic hydroxylactone, which what if in a small acidic condition we can eliminate these water molecules and get the lactone. So this could be helpful for to even introduce the late stage isotope labeling. So that's why we decided to make even lactone core. To make this 6 functionalized building block, we just did our retrosynthesis analysis and we identify this. But to make this 4 functional building block, we need only one common intermediate, this beta substituted bromolactone. And to make another 2 functional building block, we need a bromolactone building block. So to make this bromolactone, we started from the vicinal dibroma acid, which was first with the copper catalyzed addition elimination on tips alkene, and we got this addition product plus cyclized product, which was uncyclized product. We further treated with silver nitrates and gave the desired 5-dio decyclized product, which was later to convert into the lactone. Introduce the vinyl and the lactone core. We used the 2 pathway. First, we prepared the first lactone, followed by Suzuki cross coupling, or we can do either way, like the first Suzuki, and then we can convert into the lactone to lactone. And finally, after protection followed by iododesalations, get the desired idolactone substrate. To make this idolactone, when we treated the iododesylation method, we expected to get desired product, but we observed the 2 undesired product because here this vinyl is not in conjugation with the carbonyl, so it's an electron rich, so it's forming a first iodinium ion and the solvent like an hexachloroisopropanol, which was attack on the iodinium ions and form this product. And this intermediate further goes for iododesalations and get this another product. To synthesize this idolactone product, so we came with an alternate approach. So instead of acid, we started with an ester substrate. So what we did is that first we prepared with the copper catalyzed annihilation, and later instead of cyclization, we decided to introduce the vinyl group, and then we treated with an iodine and get the desired 5-hydroxylic cyclide product, which was later we did the desalination using the trifluoroacetic acid and isomerization using the catalytic of iodine to get the desired core of idolactone. So to make this another 4 functionalized building block, we needed this bromolactone, this beta substituted bromolactone. For that purpose, we started from this geminal dibromo acid, geminal idobromo acid, which was first we prepared this iodine 3 substrate followed by base free copper catalyzed annihilation to get the desired bromolactone. And to make the lactone core, we first introduced the lactone core. We first did the Suzuki cross coupling followed by iododesylation, get the idolactone core. And for lactone substrate, so either we did the same protocol, so we can do the ammonolysis on the Suzuki product, or we can do on this bromolactone first, ammonolysis followed by Suzuki cross coupling. And finally, after bulk production followed by iododesylation, get the idolactone substrate. The propane subunit purpose also we use the like nickel catalyzed reductive cross coupling followed by iododesylation, get the idolactone substrate. And for the lactone also we use the same synthetic strategy like the nickel catalyzed reductive cross coupling, followed by buck protection and iododesylation, and get the desired iodolactam substrate. So these are the to make this functionalized building block, these are the optimized reaction conditions. So while making this functionalized monocyclic functionalized building block, we encounter different challenges. But due to time concerns, I'll just explain about the three main challenges. First one, it was with the copper catalyzed annulation on this germinal hydrochloric acid. Second thing, we observe change and challenge was on to do SPT cross coupling. And the third thing is that an iododesylation on the lactam substrate. So, mm, so when we tried on the vicinal dipro substrate on copper catalyzed annulation within triethylamine, so we observed this addition elimination product. And so when we tried the same substrate on this vicinal dibromacid with the same reaction condition, so we observed the double alkyne addition and plus small amount of cyclized product. After trying several reaction conditions to try to avoid the second alkyne addition, we are not successful. So we are just going to the lots of literature, and we identified one interesting article that they used iodine 3 substrate, and they used base-free copper catalyzed annulation with terminal alkyne and get the desired bicycloride. And as per their proposed mechanism, this also the reaction goes via copper 3 intermediate, or it could go via copper 3 intermediate. And after the reductions and get the cyclic form of the desired idolactone core, sorry, lactone core. So we felt that the combination of high reactivity of iodine 3 substrate and plus the base-free condition might give a selective alkyne addition on the selective alkyne addition. So that's why purpose we prepared the iodine 3 substrate. First we treated with an ozone, later with the formic acid, and later finally with after then neutralizing with bicarbonates and get the desired iodine 3 substrate, which was confirmed using the crystallography. So we are the first group in the world that we prepared such kind of iodine 3 substrate. And later, then we did the base-free copper catalyzed annulation on this terminal alkyne, so get the desired bromolactone intermediate with acceptable amount of heat. To check the reactivity of iodine 3 substrate, we screen the different copper 1 sources, and we observe that the copper 1 chloride and the copper 1 cyanide are giving the better result as compared to other copper 1 sources. But here we decided to go with copper 1 chloride because we observed the formation of another the diacyclic dialkyl addition product in the 1%, which could make us trouble for the purification. So that's why we go with copper 1 chloride. And here also with this iodine 3 substrate, we the substrate scope, and we observe that with in the sonogashira cross coupling kind of the electron deficient alkynes are not giving the better results. So in our case with iodine 3 substrate with electron deficient alkyne on this R group are giving the better result, if you can see in this substrate or another one or this one. And even one more is that, and this was little bit helpful with our bachelor students. So the second challenge was to do sp2sp3 cross coupling. So you might have heard about the major known major name reaction like Suzuki, Nigeshi, Komada, reactive Hague, and even cross electrophile coupling. We tried more than 50 different reaction conditions to get the desired productive more. So after trying several conditions, so we came with the two different approach. Synthetic methods that are giving better results. One with an iridium catalyzed photoredox catalysis, which was developed by the Macmillan Group, who win the Nobel Prize in 2021. And the second strategy was to nickel catalyzed reductive cross coupling. So we decided to go with nickel catalyzed reductive cross coupling because these are giving this reaction setup is easy as compared to the heterodox catalyst, and plus this not time consuming process. That's why. And the third challenge was to do hydrodesylation. You might have seen that this hydrolactone substrate, we did the hydrodesylation, they're getting the desired product. But for the lactone substrate, I need to first protect, and then I need to do hydrodesylation. So what if the unprotected lactone, we go for hydrodesylation? So when we perform this reactions, we expected to get the desired reaction, but we observe the formation of this diado and the fluoroisopropyl intermediate. So we just thought how this second addition product could form. So we proposed the mechanism such a way that because this enamide bonds first is more nucleophilic, so it's for first forming adenine ion, which was later formed tertiary carbocation, which was stabilized by the silicon by hyperconjugation. So due to this hyperconjugation, now this silicon carbon bond gets weaker, so nucleophile attacks on the silicons and form this 5-bond. But this generated iodolactone product, it's immediately reacting with another adenine ion and forming a dioiminium type of intermediate, and with an hydrofluoroisopropyl addition, with imine addition, to get the formation of this diode product. So we feel that this how could we try to how we could try to avoid this second iodide addition. So we felt that if we could reduce the nucleophilicity of this enamide bond, so we could avoid the second iodide addition. So that purpose we first decided to introduce the electron withdrawing group on the nitrogen atom. So that's why purpose we first protected with the box. And then we perform the hydrodesylation. And interestingly, we get the result hydrodesylation product, and also we get the bulk protected product. So to check that one, we observed that the hydroperoxypropanol was sufficient enough acidic to clear the bulk group on this hydrodesylation product. And to prove our mechanism of that the reaction is going well, this intermediate for this on unprotected lactone, we did our control experiment with and then we observed the formation of this data product. So we synthesize. So as per our data synthesis analysis, we synthesize this 9 pre-functionalized building block to synthesize these photoxidation products of the bilirubin. So our target was to synthesize the bicyclic and tricyclic molecule, because the monocyclic photoxidation product synthesis are already known. So that's why we decided to make this bicyclic oxidation product first. So we decided to first target these two bicyclic compounds. So that purpose, we first did the Suzuki cross coupling with respect to the coupling partners, and later we converted the lactone to lactone via amylolysis, and then we perform the reaction with the to cleave the bulk group. Then we treated with trifluoroacetic acid, and we observed the turbital ester hydrolysis followed by decarboxylation to get the bulk deprotected product. But when we perform the same reaction condition on the another substrate, we observe the decomposition. Interestingly, one more thing we observed that when we did the reaction on the lactone, we observed the also decomposition. But in the other case, we on the lactone substrate, we get a desired product. But when we perform the reaction with the analysis, we observe there was no reaction. So from this experiment results, we get to know that this electron withdrawing group on the C2 position of the pyrrole is necessary to convert into the lactone to lactone. And the second thing is that on this other side, because alpha substituted vinyl on the lactone core, we need an electron withdrawing group also on C2 position of the pyrrole. Because when this electron withdrawing group absents, so the pi electron delocalization towards this vinyl bonds are more, so that's why it's getting first protonate and then it's going for the decomposition. So to make this propan diapenes, so instead of paving the whole bog group, so we decided to keep as a electron withdrawing group of the C2 position of the pyrrole. So that's why we just did the turbo hydrolysis. So we treated with the neat formic acid. So we get the desired form acid fragment, and which was further we did the photo oxidation in presence of rose Bengal gave the desired propane-diaphragm course. In this case, for this propane-diaphragm A1, A1, A2, and the for in this case propane-diaphragm B1, B2. So after completing of this propane-diaphragm synthesis, we move towards the synthesis of the tricyclic molecule called as biopenins. For the biopenins, we identified here in the biopenin that these two rings are common. So we decided to synthesize this bicyclic intermediate as a common intermediate for the both biopenin. For that purpose, we first did the Suzuki cross coupling, followed by after Suzuki cross coupling, we did the Bogdy protection so from the bicyclic intermediate, which was functionalized using the iridium catalyzed correlation with the desired common precursor. When we try to make the lactam substrate, we get the bicyclic core, but when we try to functionalize using the iridium catalyzed correlation, we observed there was no reaction even after protecting with an FMOP on the nitrogen lactam core. So we decided to go with move forward with the lactone core. So that purpose, this lactone core first we did the Suzuki cross coupling with respect to lactone core and even the lactam core. And here we observe this tricyclic core with the Suzuki cross coupling product, which is the lactones are giving better result as compared to the lactam. Then we did this ammonolysis and followed by ammonolysis get the desired bioperin A. So you might think that why I need on the biolactone case there are two cycles of ammonolysis. So because as I said to you that when we treated with an ammonia, it's forming an hydroxylactone. So now this, if you'll see the C2 position of the pyrrole, there is not electron withdrawing. Now the electron group is absent. So as per our previous observation that we need an electron withdrawing group of C2 position on converting the lactone for lactone. So that's why the second ammonia addition of the another lactone is getting called. So that was to introduce the electron withdrawing group of the C2 position. So first we need to eliminate the water molecule. So that's why we need to eliminate, we treat it with formic acid. We make the lactam core and then we perform the another cycle and get the desired bilactam cores called as bioperin, which was for the hydrolysis get the bioperin A. So using the same synthetic strategy, we use for the bioperin B. First, also we couple with the Suzuki cross coupling on the lactone and even the lactam core to get the desired bicyclic lactone core, bioperin core, and later ammonolysis followed by hydrolysis get the bioperin B. So this is the first photosynthesis of the bioperin A and even for bioperin B. So Ming, so we studied the phototherapy of the bioperin A. And this was in performed with under collaboration with Professor Peter Glan group. So they treated the this bioperin A. They irradiated with the bioperin A and get they see the formation of this isomerized bioperin A and even cyclic formation of the compound. So this cyclic compound are unknown. So to introduce this nomenclature to the world, so we decided to use the nomenclature from the based on the compound called as lumirubin because this cycle is called as core is the same. So we gave the nomenclature as a lumipirin because this lumi is derived from the light, so that's why called as lumipirin. So our synthetic strategy is so diverse that we can paper the parent compound like the biliverdin and bilirubin. So that purpose, we first prepared the bicyclic intermediate via Suzuki cross coupling, followed by uh, by terbital hydrolysis, followed by decarboxylation. And another functional building block we prepared from the Suzuki cross coupling with this pharmaceutical functional building block. And after uh, treating with sulfuric acid in methanol, we get the desired biliverdin dimethyl ester. and with an excellent yield and formal, and finally after its hydrolysis get the biliverdin, and this biliverdin further reduce with the sodium borohydrides and gets an bilirubin. Using this synthetic same strategy we use for isotopal label, and we first prepare the lactam course using the ammonium acetate, and followed by, so we prepared the bicyclic intermediate and intermediates, and which was further converted into biliverdin and followed by hydrolysis getting biliverdin. So now, due to some, we also prepared the bilirubin and even tetrasubstituted level bilirubin from the synthetic strategy. So these are unpublished results, so I cannot show it to you. So this, if you see the conclusion that we prepare the diverse functional building block, which are is also useful for the other medicinal chemistry projects and also for other bioactive molecule synthesis. So we prepared the three functionalized pyral building block from commercially available material like succinic anhydride and methyl acrylate. We developed the new iodine iodine 3 reagent, which was further, we also developed the synthesis strategy for the basically copper catalyzed annihilation. And this methodology we implemented in our synthesis to make this 4 functionalized building block. Another 2 functionalized building block prepared from the vicinal dibromo acid. And from this functional building block, we prepared the we also prepared these monocyclic photooxidation products, which was by under the my bachelor and master student under the supervision of me. And we first prepared the bicyclic oxidation products of the bilirubin called as propiondiapanes. We prepared the tricyclic molecular photooxidation products of biopyrene. We also prepared the parent compound like biliverdin and bilirubin, and also we use this synthetic methodology to introduce the unpipped isotopically labeled nitrogen atoms on the biliverdin and bilirubin core. And we also studied this photochemistry of biopyrene A, and we get the desired new cyclic compound, which is called as, and give the nomenclature for this molecule as lumefantrine. This result was published in the peer-reviewed journals like JACS and JOS articles. You can find it on AC's website. So I'll just give just an overview towards the Honochiola Daclatas with synthesis. So if you see this Honochial structure, this is the biphenyl compound, and which is a neurotropic agent. And this project came from the Colgate Polymer project. So they want to synthesize the new synthetic strategy to synthesize this Honochial. And here we can't use the strong acid or even the strong acidic condition, basic or acidic condition, because the problem is that the electron here, this in the basic condition, if this proton is getting acidic, so it's getting isomerized, the double bond gets migrates here and forming a stable compound. So we developed the strategy using the mild conditions. So we started from the 4-bromophenol. First, on this 4-bromophenol, either we could go by propyl addition using Komoda cross coupling, followed by lithium and borylation, get the borated intermediate, and another intermediate was using from the Claisen rearrangement, followed, and finally after Suzuki cross coupling, followed by MOM productions, get the these are Honochial synthesis. And regarding the Daclatas wave, so this is then Daclatas wave structure is an if you see this an symmetric molecule. And this Daclatas we use as a hepatitis C drug, and which is given with the combination of super. So we decided the project was to design a synthetic strategy using the flow methodology. So to make that one, so we needed this bicyclic intermediate, this biphenolic intermediate. This biphenolic intermediate was prepared via 2 pathways. First, we did the Ullmann reaction, and followed by Friedel-Crafts acylations, get the bicyclic acyl intermediate, or other we could start with the 4-bromoacetophenol, with an Ullmann reaction followed by chlorination to get this biphenolic intermediate, which was further later we did the esterification with this proline derived peptide. So we did the esterification. So in the flow method, so we introduced the two different channels where we pump it from the one side with the biphenyl intermediate, and another from this acrolein peptide intermediate. So get the by this ester derivative, which was then you treated with an ammonium acetate and get the desired imidazole formation. And this is the flow synthetic methodology we use to synthesize this dark light acid, which is also get patented in the US patent. So I'd like to thank you to my supervisor here, like Masaryk University, for this constant support and constant support and supporting for my research ideas. I would like to thank you, my group members, all of my collaborators, funding, and I also like to thank you for this funding agency. Without their funding agency, we not accomplish this result. And I also like to thank you for giving me an invitation for such a good conference. And I would like to, and I will be happy to answer your question. And thank you for your attention.
Sir, thank you. Thank you very much. Here, Dr. Muzawar deliver very nice and informative presentation. Now, I would like to announce the topic is open for discussion. Rashidi ma'am, namaskar. Rashidi ma'am, any question?
Yes, sir.
Any question from the research scholars? Okay, thank you. Thank you very much. Dr. Muzawar delivered the very nice and informative lecture today on sustainable synthetic strategies for bioactive molecules from design to scalable chemistry. He clearly explained the synthetic strategies of monocyclic building block, and his strategies focuses on developing environmentally again cost effective and efficient methods for producing bioactive molecules such as pharmaceuticals, natural products derivative, etc. Mr. Muzawar had explained very clearly the role of bilirubin in the human body and its complete mechanism. Finally, I hope that the presentation will very useful for the research scholar and faculty members. Thank you. Thank you very much. Lastly, again, I would like to express my sincere thanks to organizers, Dr. Mujawar sir, principal of this college, vice principal of this college, convener of the conference, all the researchers. Thank you. Thank you very much. And now I declare that here the today's first technical session is over here. Thank you. Thank you very much. And I will hand over the charge to the convener of the conference. Namaskar.
Namaskar. Thank you for
Sir, namaskar. Thank you.
Thank you for organizing the meeting. Thank you.
Thank you so much, sir. Thank you to the chairman of this session, Dr. Dhokle sir, as well as the resource person, Dr. Mujawar sir. Sir has shared their valuable knowledge, expertise with us, and I'm very grateful to him. Thanks a lot, sir, for giving you a valuable time. Thank you, sir.
Thank you. Thank you for giving me an
Thank you.
opportunity.
Bageshwar sir, thank
so
you.
much.
Madam, thank you.
Thank you, respected sir. Knowledge shared is the knowledge multiplied, and innovation begins with a discussion. This is the motto of this international interdisciplinary conference. We will really appreciate if the participants can ask their queries, because such esteemed dignitaries are present with us on this online platform, and it will be honorable for us to have discussion on this platform. So thank you all the respected dignitaries who have contributed in the first session of this conference. Now, moving towards the second session, the second technical session of this conference, I invite Professor Dr. Rajesh Wankhede, Head, Department of Chemistry, BP Science College, Digras, as well as the Vice President of Amravati University Chemistry Teachers Association, OCTA. Hello, Dr. Wankhede, sir. Hello, Dr.
Hello.
Wankhede, sir. Please unmute
Hello.
yourself.
Hello.
Hello, yes, sir. You are audible. Yes, sir, audible.
Yes, yes, yes.
Welcome,
I joined.
welcome, sir.
Thank you, sir.
For this session, we have resource person, Dr. Jnaneshwar Badu An, postdoctoral research fellow, National University, Singapore. His topic of presentation is continuous flow technologies for sustainable chemical synthesis. So without taking much time, I hand over this session to Dr. Wankhede sir. On the behalf of organizing committee, I wholeheartedly welcome our chairperson of this session, Dr. Wankhede sir, and the resource person, Dr. Jnaneshwar Badu An sir. Over to Dr. Wankhede sir.
Good morning, everybody. I, Professor Rajesh Wankhede, Head Department of Chemistry, BBRs, NB Commerce, and BP Science College, Digras, District Yavatmal. Welcome you in the technical session 2 of day 2 of International Interdisciplinary Conference on Material Science and Knowledge Convergence, Recent Advances for Sustainable Development 2026. First, I congratulate Dr. S.B. Chakwesar, Principal of Mungsaji Maharaj Mahavidyalaya, Darwa, both the conveners, Professor Dr. P.D. Bageshwar sir and Professor Dr. N.A. Rashidi ma'am for organizing the international conference. In this session, we are very fortunate to have Dr. Jnaneshwar Balu Ansar, an eminent scientist, as a speaker. These my words are due to his very impressive CV. His CV is very long, but considering the time limit, I have focused on his few important achievements. I have immense pleasure to put this CV before you. He is research fellow working in Professor Saif Khan's group at Department of Chemical and Biomolecular Engineering, National University of Singapore. He has done his MSc in Organic Chemistry in 2017 from School of Chemical Science, Solapur University. He was awarded PhD in 2024. His PhD work is focused on flow technology. He is a CSIR NET JRF and get researcher. His publications are in reputed journals with multiple high impact. These journals are Reaction Chemistry and Engineering, Green Chemistry, ACS Sustainable Chemistry and Engineering, International Journal of Hydrogen Energy, Applied Surface Science, European Journal of Organic Chemistry, etc. Finally, I would like to say about Dr. Answer that he is chemist by passion and innovator by nature, driven by curiosity to develop sustainable chemical technologies and efficient process solutions. Now, I request Dr. Answer to deliver his talk on continuous flow technologies for sustainable chemical synthesis. Sir, please.
Thank you, sir. Are you able to see my slides, sir?
Yes, sir. The presentation is shared.
Okay, thank you very much. Good morning, all of you. I am introducing myself first. I am Dr. Anand Naneshwar Babu. I am from Solapur. I completed my MSc in 2017 from Solapur University, Solapur. After that, I joined as a CSIR IICT as a project assistant. And later I qualified CSI JRF and I joined as a PhD student and I have completed my PhD in 2024. And in my PhD, I work on the continuous flow technologies for the sustainable synthesis. And after PhD, I move on the National University of Singapore. I'm here also working on the continuous flow reactor designing. So today I'm presenting work on the continuous flow synthesis for the sustainable chemical synthesis. So firstly, I will first told you what is the flow chemistry. In the flow chemistry, we are performing reaction in the continuous in the tubular or cap in the capillary, and we will injecting continuously starting material and the reaction happening in the reactor, and we will get the product. So in our conventional traditional batch chemistry, what we do, we are all reagent we are added in the room as the round bottom flask, and reaction proceed over the time, and the here is the limitation of the in batch chemistry when we want to perform the like some controlled reaction like a high temperature, high pressure, and mixing. If you consider the temperature, we cannot go beyond the boiling point of the solvent. But in the flow chemistry, we can apply the temperature uh, as possible as what at the temperature your starting material not at degrade. So we can apply the higher temperature, and this reactor is the very small space required. You can perform the high mass transfer, and you can easily scalable, and you can produce the product very highly in the very short resistance time and the high selectivity. So this is the basic anatomy of the flow reactor. So in the flow chemistry means is the bridging between organic chemistry and chemical engineering. Is the like the yesterday Nakate sir is told is we need to learn the engineering because we are not chemistry, because engineering not the degree, it's the technique. So I'm also adopted this technique and the flow chemistry after my MSc, because I'm also not an engineering background, but it's almost bridging between chemistry and the engineering, because engineering most person know about that they how to design the reactor and that things, but they don't know about the how to perform the reaction. So but we well known about the how to perform reaction, we know about the we learn a lot of chemistry, so we can easily understand the setup and that things. So here is the compound is the in the anatomy of the flow reactor. First is the region delivery zone. Means here is the we need to pump, where is the inject the our starting material in the reactor with the specific rate. So therefore we require the HPLC pump or parachute pump, so that will inject the solution. After solution, if you have the multiple reactant, we can use the multiple pump, or you can make the if our reaction are not happening at the solution at the ones at the stock solution, you can mix together, and then there's this solution mixed together at the mixer zone. And here is the various kind of mixer are used, like a quad mixer, Y mixer, T mixer. Also now the in the market, so the very in the various lab they design the various kind of mixers currently. So after that, this is the reactor zone. In the reactor zone, we can perform heating, cooling, oscillator, microwave, electrochemistry, photochemistry, and the ultrasound reaction. And this various kind of reactor also, we can have coil reactor, chip reactor, and packed bed reactor. Like the for the heterogeneous reaction, we need to the packed bed reactor. If you do the heterogeneous reaction in batch, we need to the after reaction we need to filtrate, dry the heterogeneous catalysis, and then you need to again activate. But in this reactor, the catalysis, we can use the we will get the higher turnover number, because of the we do not need to filter the catalyst is still remaining the in the reactor. We just flowing the solution, and after whatever optimized condition, we will get the directly product from the filtrated. We didn't need not to remove and filtrate this condition. These steps we are skip in the flow chemistry. Another next zone is a quenching zone. In this, if your reaction required after quenching, like organic metallic, if you do the reaction or feeder cap acylation, we will do the feeder cap also the inflow. So that time we need require the quenching, and at the reactor with a solution coming out, we need to quench, or any toxic reagent like the diazomethane or anything, we need to quench that one. And so quenching zone is required. After quenching, we put the pressure regulator. The pressure regulator is required if you are the applying the temperature for the beyond the boiling point of that solvent, or you are using, if you are using the gas liquid phase, because of the liquid has the required more space, so we are required to compress it, and therefore we use the pressure regulator. After that, the downstream unit and the inline analysis, these are the optional. So we can up that unit we can apply it or not. That's not necessary. If you want to automation, or then you need to apply the inline analysis and that unit. But and after that, the collection zone, where we will the continuous collecting our the product. So why we run the reaction in flow? So here is the some advantages of the reaction. Advantages of the reaction performing in flow, because we can increase the process safety, improve production quality, process reliability, reproduce, increase the sustainability, and the flexible production. We can scale up easily with the from the stacking, multiple stacking the small reactor, or the just the increasing diameter of the reactor, or the increasing length of reactor. So, and which kind of reaction we perform in the flow reactor? So we So we can perform the flash chemistry, high temperature, thermal temperature pressure reaction, gas liquid reaction, catalysis like a heterogeneous reaction, multi-step API, multi-phase reaction, photochemistry, electrochemistry, some bioenzymatic or material chemistry where there is hydrogen production or the mechanochemistry, and last is the digitalization. This like because of the AI, some now group are they are working on AI, so they are connecting the flow reactor on the their own code, and they are to automatic optimize the reaction. So these are the current continuous flow chemistry market in the 2025, and you can see the most of the US and Europe also they have high percentage of the flow chemistry marketing in the API and some other you can see the energy conversion, agrochemical, material science, and pharmaceutical, and mostly for and petroleum also they're not mentioning here, but previously the concept of flow chemistry start from the petroleum. They are introduced first in the petroleum. Now we are applying in the organic synthesis. So key important parameter in the flow regarding the flow chemistry, the flow rate. Flow rate is the what how much fluid we are injecting in the reactor per time is called a flow rate, and the residence time of the volume of reactor divided by the flow rate means the residence time we will consider as the reaction time in the as in traditional batch, because in the residence time the whatever we are injecting reactant and starting material or just staying in that time, that during time in the reactor and perform reaction directly we will get the product. And like in batch also we will get the we need to calculate the stoichiometric ratio upon the about catalyst, reagent, additives. So we can in the flow we can all control by flow rate, and if you each solution if you are passing injecting by the separate pump. And then last is the number of moles. Turnover number is calculated upon the number of reactant consumed per mole of catalyst, and this is the turnover it's very high in when you are applying the flow chemistry, because of the packed bed reactor it will not allow easily to deactivate the catalysis, because of you need not to uh, filtration and that thing that expose the minimum oxygen and aqueous condition, so that will retain the more times to the catalyst activity. So here I will give some detailed information about the photoflow chemistry fundamentals, why we use the photoflow. So photochemistry reaction are driven by absorbing photons and consequently homogeneous energy distribution inside the photochemical reactor. And due to that one, we will get the high yield and high selectivity, and we can control the time of exposure, because if you expose perform reaction in batch, what will happen, the starting material react after absorbing and form the product. In product also if you active again, so it will give the byproduct with the our reagent, so that will all positive we are neglecting the flow reactor. And first in the flow reactor will the improve the irradiation of reaction means what the everybody will know the well known the Lambert-Beer's law in the and according to Lambert-Beer's law, the radiation distribution will not inform the in the reactor due to absorbance effect, because of the depth of the radiation is depends upon the concentration, the light depth, and these are the if you consider in the batch reactor. If you consider the batch reactor and the flow reactor need to be you consider 1 mm only, and you can compare the both parameter for the 20 ml round bottom flask and the 10 ml tubing, PFA tubing, and light exposure area is around 31 cm square in the 25 ml RB if you consider 10 ml solution, and the same kind of if you consider the 400 cm square light exposure area, it's almost 10 times but more than that one. And if you consider the time area and path length also, if you consider the path length is very much higher, is not ideal for the better efficiency, but in the in the flow reactor it's only 0.5 mm, and it can perform very well reaction. So we can put in the flow in photo flow, we also perform the multi-phase reaction. If you consider gas, liquid, and liquid solid reaction in the batch, if you consider the like any hydrogenation reaction, if you performing, and we need to perform like a liquid, our starting material liquid in the around bottom plus, and we put the hydrogen balloon on the top, and only the at the surface area it will give the interfacial between the liquid and the gas. But in flow that all problem is solved in the flow, because of the we will pass the sludge flow gas liquid droplets, and it will due to that one the interfacial area of the gas liquid is very high, and therefore it will perform the very well reaction. Also another is the membrane reactor. In the membrane reactor, it is called a tube also reactor, and this is the inside the tubing we are flowing the reactant, and outside tubing we are flowing the gas reactant gas is the carbon monoxide, as methane or whatever, and that membrane is permeable membrane, it's all of the gas, so gas is react with the material, and it will get the only product we know not to quenching and that things. Another for the uh, for polymer synthesis, if you consider the polymers in photochemical reaction, if you perform the polymer synthesis, the due to the reaction, we will not get the homogeneous dispersion. But if we are using the segmented sludge flow, we will use the like a gas oil aqueous method, oil aqueous phase, so it will give the separate phase between two the droplets, and it will form the homogeneous dispersed material, and the narrow particle, whatever particle size we will get, we will get that size according to how we will make the droplet size. So another is mixing is very high in flow reactor, because of the in the flow reactor is the micro channel, and inside the micro channel there are Reynolds number very high, but that's but therefore it's enhance the mass transfer and the high selectivity. And if you consider that uh, uh, in the batch will not get that much high Reynolds number, also it will give the high tiny PFA tubes, and any kind of tubular reactor capillary, it's 1 mm or something, it has the larger area. So it will, if you want to perform any thermal reaction, if you want performing that reaction in batch, is just 70 minus 70 or something, that same kind of reaction we can perform in flow reactor at the 0 degree or the room temperature. So another this scale up was for the scale up reaction in flow is very easy, and we can opt for the any industry or uh, industry or any kind of reaction, the scalability is a challenging task in the flow chemistry. For if you consider the big reactor and perform is then just in batch of the reactor and just apply the light from the side all, the depth of the light penetrating inside is very in some few millimeter, and the diameter of that reactor you will consider in the production scale is around the in some centimeter, and therefore the production is will not easily scale up in the batch reactor. But a flow reactor, you can just stack multiple same kind of reactor, just stacking that together, or the just increase the length of the reactor, or just little bit increase the size and length of the reactor. We will perform lab scale EMG to the some kilogram per day or kg per hour. Also we perform the produce the product. Also increase the, because of the we applied the homogeneous light radiation, as well as the we control the reaction time, exact control reaction time, photons. So we will get the better selectivity and the increase the reproducibility. The another fun factor here is that we can perform a multi-step reaction, because if you can perform the reaction, some you want to perform the any product. So whatever the we will need the like a compound A and B, and the perform the product, we need to work up isolation, and then we perform another reaction. And then if you get that product, we need to again work up isolation, and then we will perform the third reaction, and then we will get the product and outcome. But in flow, no need that one. We can just start reaction flow reactor. We inline we can apply the in a micro separator or inline downstream process. We applied that and directly in after that process we inject in reagent third, and then reagent second, and after that reaction again downstream process, and we are again at the reagents third, and we will get the final product here without the any in between disturbance, and we will get the final product. And some kind of the here the toxic material also, like diazomethane, ozone, and the any azides. We can Grignard reagent also we perform the we using this flow chemistry, we inline with generate that intermediate and perform reaction, and after that we safely quench the that reagent, as well as we get the product. Because of this diazomethane, as the diazomethane and every hazardous chemical in high scale, mostly industry do not want to apply. They avoid this kind of things. So here I will start first what I perform work in my some PhD works. So I'll start here. The phthalides are the bicyclic compound and broad pharmaceutical and synthetic utility. And this the phthalide synthesis in the current previous method, all these are the using the activated groups and using the transition metal or non-metal in the cyclization reactor, lactonization or condensation. But the all the this method noble metal are transition metal are expensive or rarely or method. So after that the some group have developed photochemical in batch reaction, but they required the 3 days reaction from the activated groups. Also, some using the sodium cyanide as a toxic reagent, and most cannot want to use this kind of toxic reagent, highly toxic. Also, some group that developed the electrolyte cyclization method from the they need to activate again activated groups, and this required a high excess of electrolyte. Also microbial addition in enzymatic reaction also perform the thalide synthesis, but they require high reaction time. So here we perform the reaction from the 2-methyl substituted 2-methyl benzophenone, and that would synthesize easily from the feeder craft acylation with the benzyl source, benzene or the xylene as the starting material, with the acyl chloride, which we synthesize from the benzoic acid, and we use that substitute 2-methyl benzophenone as the substrate in DMSO, and using a gas oxygen as the oxidant, and that perform a reaction in the photoflow reactor under medium pressure lamp for the 365 lamp nanometer lamp, and after reaction we quench in the in line with downstream processes at the extraction and separation, and after that we will get the product. After that product also we will do the next step reaction from this Michael addition with the chalcone and another the reduction using a H cube. Is the H cube is the hydrogen generator that will use the that generate the hydrogen from the electricity, and there is we put the hydrogen catalyst cartridge, and that will perform reaction inbuilt, and we will get the product. So here is the design of the that reactor, whatever we use the reactor. So basically we are using the compound one in the as the stock solution, and pump for the delivery, and oxygen cylinder we directly connect to MFC, and that MFC we will MFC and both are mixed together as a T junction and flowing to the reactor. In the reactor we use the PFA to be the good for the photochemical reaction. Most photochemical PFA and PEPF tubing are used. And also we are using the water circulation because of the 365 nanometer lamp is the high, and is the 250 watt reactor light source we are using. It generate huge light heat. Therefore we need to control the temperature of the reaction also. So we apply the continuous cooling water and from the coolant, and we will get recirculation to control temperature. And you can see that this picture for the one is a you can see the gas liquid segmented in visible light, but you can see in the ultraviolet lights you will get the homogeneous light gas liquid surge flow. You can clearly you can see that one. So after the reactor designing reaction performance, we design another the liquid separator. So in this separator, we are the two. This is the metal holder. In between, with this is the uh, uh, PFA. We have in our previous lab we have that laser cutter. So we design our reactor, and this is the protective sheet. After that, this is the channel. We use this two channel. In between, we kept this is the membrane, PTP membrane for the it's a hydrophobic membrane for the aqueous organic separation. So here is the we start the reaction with optimization of the product. We perform well many reaction with the we change the ratio of the hydrogen. We are starting material and oxygen gas ratio, and at the 0.1 ml flow rate of the compound 1 and 1 ml flow rate of oxygen gas, we will get at the 12.1 minute residence time. We will get the 90% by the GCMS and 85% is isolated yield, and we'll get only 3% as the aldehyde. Then we perform the various solvent screening also, but we will get only chlorobenzene and DMSO is the best. But we choose the DMSO instead of that one. So after the optimization, reaction optimization, we also optimize this extraction escape that optimization table. And after that optimization, we will perform that whole reactor setup, and that according to that to optimize condition, we perform the various reaction. We make the library of compound, and this various substrate, and all these substrate we had developed synthesized by the simple Peter capsid method. And after that we synthesize the one of the like a n butyl thalamide. It is used for the hypertension. It is API used for the hypertension treatment. After the synthesis of library, we also use the that's whatever the compound one coming from the micro separator. We are adding the methanol because of the hydrogenation. Methanol is necessary, and in the H cube itself it generate the hydrogen, and the hydrogen from the water by electrolysis, and that hydrogen is participating in the reaction, and we do the reaction of the phthalate. We will get this reduction product. Also, we will use the chalcone and the KOH and crown ether in the toluene as the stock solution, and whatever the starting material from the coming from the micro separator of the product one, and both are varied temperature and pressure, and we'll get this product. And after the synthesis optimization of both reaction, we make the whole integrated setup for the reaction of the sampling and reaction, after reaction extraction, separation, and with that product, in that products also is late stage functionalization under the uh, late stage functionalization. And the possible mechanism of this one, the 2-methyl-benzophenone is itself as the absorb the light source as a 365. It will get excited. After excited, it will go the 1,4 hydrogen transfer and will form the this diene complex. And this diene with the cyclization with the oxygen will get this the third, and this third intramolecular intramolecular we got the dehydrogenation and uh, uh, dehydrolysis, and we'll get the this aldehyde intermediate whatever we observe in the reaction. And this reaction aldehyde again we will get under light exposure, it will got excited from this ketene intermediate, and ketene undergo intramolecular cyclization, it will form the phthalide. Second, same kind of work we had done, the we observed that this molecule is very good for the light absorbance, and some paper they try to do the carbon dioxide as a hydrogenation reaction. Then when we try the whatever the hydrogenation reaction they perform in this, why we not try to the whatever the exhaust gas coming from the bike, and that coming that content also hydrogen gas. So that gas previously some approaches for the hydrogen gas capture, they are come water the gas is coming from the combustion, they trap in the adsorbents, then they require a release hydrogen for the increase the then after absorbance they require to provide a high temperature to release that carbon dioxide, and that carbon dioxide then from the reaction of the storage, and they use for the next reaction. Here we try to do the first direct. Can we do the direct exhaust gas for the reaction? In that concept, we try to do. Then we perform here reaction with the two same reactor, and we apply the multiple the inline separation. We will do the product. For the product, we scan here the inline analysis of the gas content of the various bikes, and continuous we monitor their carbon dioxide ratio, and then we perform the reaction. Here you optimize the reaction with the maintaining the various ratio of exhaust gas and the starting material ratio, and we'll get the yield. And because of the exhaust gas containing oxygen also, so we'll get here the around 45% of the carboxylated compound, and around 30% of the uh, phthalate product. And here same the whatever the our we performing reaction under sunlight, we'll get that product. That product again we applied the our using our homemade micro separators in series. We optimize the inline complete aqueous separation and compound purification because of the carbon dioxide carboxylic acid whatever form we adding the aqueous base, we quench it, and then we extract only phthalate, and then we again it's acidified, and then we'll get the uh, pure carbon dioxide carboxylated products. And here also we make this library of compound. Then the next is the photochemical reaction optimization platform. Here we try to the synthesis of the certain intermediate, and for the certain intermediate is the this 2A compound is required for the bromination, but in the bromination, monobromination or dibromination it's the dibromination also imperative form, and it will take in batch various it's at around 24-minute residence times. Also, after that whatever the brominated compound, we need to require the 3-MIT with the nucleophilic substitution, and that required like -8 to 12 per hour, 12 degrees Celsius or 3 hours at room temperature. We required additive because of the sodium hydroxide. Okay, to see at the base, they have the very less uh, solubility in the organic solvent. Therefore, we synthesize this certain intermediate in continuous flow. Therefore, for the optimization of photochemical reaction, we applied the Bayesian optimized based Python code for the optimization. That Python code is designed from, developed by the one of the collaborator from the South Korea and from the chemical engineering department, and we applied this from the optimization. And here that Bayesian code automatically we give the some range of the variables, and according to that one, it will the first applied some random reaction, and that will continuously analyzed by flow inline IR, and after analysis we will collect the product from the auto sampler, and that auto sampler we again cross by our reaction result with the inline analysis, and according then it will the fine tuning of the reaction condition, and it will give the better reaction condition. We can see that this is the some condition we try in the 0.25 molar, and this is the 0.5 molar. 0.5 molar we do not get as much as better with this try to fine tuning, but some around 80% maximum will get the yield because of high concentration. Sometimes it not get the every molecule under irradiation. That the issue. If you can just it the 0.25 molar is that little bit diluted, and this will give the better around more than 90% yield. So after that, we will the previously we designed the smaller reactor because our fluoride microfluid liquid separator, because our that fluoride is very small one. After that, we make this one is a 30 ml micro separator for the inline extraction, and we perform the reaction in the ethyl acetate as 2.5 molar, and NBS we get little bit excess as the 0.1 equivalent, and we perform the reaction with the equal flow rate, and under 60 watt light we get the bromination within 1 minute reaction time. And then we quenching with the water, and then extraction because of ethyl acetate to be extracted, and then we'll get the separation, and we get this brominator product according to our this setup. Then we try with the various methyl substituted compound for the bromination, and we'll get the very good yield. Then we design the pilot scale solar panel reactor, because we know solar as the sunflower is moving direction with the sun. According to that concept, we perform because of the if you are performing some reaction, the photochemical reaction, sun is the universal light source for the photochemical reaction. But due to the sunlight, sun is always moving from the therefore we need to the reactor whatever that move towards the sun direction. So here we perform, therefore we make the setup for that solar panel reactor. We are using the Arduino motor, and we program the direction. We keep this plate for 45 degrees Celsius, and we make the we optimize the direction of with the time, and according to we make the program. And after at the evening, this reactor it will again come to its original position for the next step performing reaction. And also this reactor we put the some my LDR chip that give the command to flow according to the light intensity of sun. So if you sometimes the cloud came, then not the sufficient light source, then it will stop the reaction. If you against sunlight increase the intensity, it will start the reaction. So if this reaction we perform, initially we make the smaller lab scale reactor. So that is 60 mml reactor. If you see 60 mml reactor, you get the 50 ml per minute reaction flow rate of the both reactant with the high concentration. With the blue light, we not we try with the 2.5 molar, we're not getting that above 80. But if you try the sunlight, because the sunlight is very high intensity, I will get the easily 92% yield with the only 32-second reaction time. And that react whatever the we are productivity is the 112 gram per hours. And it's very high production of the only just 16 ml reactor. And same we perform make that's solar tracker reactor. We make that this here we use the 1 mm tubing, but this bigger reactor we use the 4 mm tubing. And we try reaction, we get 100 ml flow rate with the 5-minute residence time, we get the 93% each. And here product with the 69 gram per hours. But in this reactor we haven't applied the mixer. Therefore it reaction take the more time. And we are still working on that, how to make the insert the mixture bit for the more better irradiation. And then we will get the same kind of the just within the instead of 30 up to 1 minute residence times, then definitely we will reach this production, from 769 to the around 2 gram per hour, 2 kg per hour production. Then we design the again the packed bed reactor for the next step, nucleophilic substitution. This is the small packed bed reactors for this reaction. This is the brominated compound, and this is the nucleophile. We need to do the reaction. Initially, we try the some with the phase transfer catalyst and the base, but will not getting that much yield. Then we move towards the packed bed reactor. In packed bed reactor, initially we use the small reactor cartridge and we perform the reaction, we'll get the better result. Then move towards the we increase the packed bed reactor size, and you can see the both the pump for the one for the brominated compound and from the nucleophile, and that both are mixed together with the mixer. And then it going towards the packed bed reaction for the performing in the heating reaction for the 6 degree Celsius, you will get the product. So this is the optimization table for the in packed bed reaction for the nucleophilic substitution, and we will get the better as the 95% as the in by the LCMS, and we'll get the 89% as the isolated yield from this product. And after that, this is the low certain intermediate. After that, we need to do the imidazole formation, but I'm trying my best, but I'm not successful. That one will get the around 30-40% yield, but not completely. Therefore, I am not still. I'm trying to do that one. So after the successful synthesis of the two-step integrated setups, we perform the various intermediate nucleophile of the various like a olmesartan, losartan, and candesartan. Also tell me certain that nucleophile, because of the this all certain intimate, this core moiety is the same moiety, only to change need to change the nucleophile, and this nucleophile will vary change the stock solution, and we perform the reaction, and we will get the every around the 70 more than 70%, almost every certain group we will get that product. Then we do the scale up of that certain intermediate nucleophilic substitution. Initially, we are using the 7 ml reactor, and that will give the around milligram per hour production. From milligram to we use this 100 ml packed bed reactor, and then move to we perform reaction in 1 ml reactor, and then we optimize, and we will get the around 760 gram per hour the productivity of this low Saturn intermediate, and then we will perform the catalysis, the packed bed reactor, small reactor, packed bed reactor with long-term activity of that cartridge we tested, and up to around 48 hours you can see that the still yield is same, but after that the concentration of that uh, yield is decreasing due to the amount of keto almost that time is around 90, more than 90% of keto CO2 already consumed. And the advantages of this packed bed reactor, because of the fine particle of the keto CO2, it will give the more dispersion in this packed bed reactor, and that gives the high intersurfacial area between the keto base and the in stock solution. They found reaction performing very short residence time. After that, work on another the toxic intermediate. This is diazomethane, and diazomethane as the is the compound, very active compound, and it will give the methylation or various kind of reaction with the 100% efficiency. It will generate only with the nitrogen as the byproduct. Some methylation and pyrazole synthesis is whole multi inserted with the alkyne or alkene from the cycle addition, and it will give the pyrazole also. And this is the diazomethane synthesized from the precursor like NMO, disalt, and the nitrosogordinamide. The these are used for the diazomethane synthesis precursor, and using the base the form the diazomethane, but diazomethane is very toxic and carcinogenous, but this is very useful for the reaction, and very short, within short time it will give the product. Therefore, we make this diazomethane in the continuous flow manner, and we make this diazomethane generator by optimizing the reaction condition within the 0.3 ml, 3 ml fluoride of KOH and NME in the ether, and the KOH in water, get the within 3.3 minutes for the reaction time, and 1.2 minutes separation time, we'll get this diazomethane. And diazomethane, this all yield we are calculated based on the titration with the benzoic acid, because of diazomethane is not stable, it's called carcinic as well as its explosive, so we need to quench that one, and it's quenching we will get the product. And after that we also make the solid quencher MF for the diazomethane quenching, and it will work as well as indicator. So after synthesis of diazomethane platform, we make the various like a methylation of carboxylic acids, and methylation of phenols, and methylation of pyrazole, as well as the with using a phenylacetylene we do the perform the pyrazole formation, as well as the alpha diazoketone formation, and this alpha diazomethane we again perform use for the various in pharmaceutical intermediate. So next here, the advantages of electroflow reactor. Electroflow reactor also same as as the photochemistry. Also electrochemistry in flow reactor is the high many advantages. Here we can do the reliable scale up, liquid less electrolyte. We handle the multi-phase, and we also the electro in the flow reactor. The interdistance between the two electrode is very less it's around in mm, so it will the potential difference between the whatever the require resistance between two electrode, it will reduce, and they will perform the reaction. You can see the some of the group has reported reaction in the very short residence time, and they will get the very good yield as compared to a batch. Also, we can easily scale up by you can see the stacking the reactor together, multiple stacking and increasing length. They have synthesized the product, and this is the paper the Oliver Koppe group. They have designed the spinning flow reactors, and they will uh, synthesize around the 1 gram, 11 gram per hour yield of the product. Some continuous flash chemistry also issues done workup. Many flash chemistry are done recently in flow with because of the very short residence time. You can see that the only 25 nanoliter is the reactor volume, chip volume, and they perform the lithiation reaction. And after they using a lithiobenzene as the lithiation source, and after this iodine lithium interchange exchange the if you do this long residence time, the cyclization intermolecular feeder cup acylation form, and that will give the this 2.3 molecule, and this will go again then reaction. You can see here that they put the only millisecond the residence time. If they put the 620 millisecond, they will the 91% of the compound 2.3, and if they reduce the residence time within 3.3 millisecond, they will give this is the product with the 91% yield. Same kind of the exothermic reaction, the Newell and co-worker reported in 2017. They performed the diaryl iodinium salt. They widely use this salt are used in various reaction as the electrophile in the organic chemistry. But the synthesis of this one is the exothermic reaction, and for this exothermic reaction in the batch required is performing reaction is minus 78 to 80. But in the in flow reaction, that's reaction performed within 10-minute perform in the 2 to 60 second reaction residence time, and the room temperature is the important factor here, because you know not to perform reaction minus 70 to 80. And next is the multi-step reaction, and the Lehman and co-workers, they also developed this the multi-step platform from the aldehyde. This the amine group. They do the TAP and sodium nitrate for the diazonium salt. This diazonium salt then they give the reaction for this nucleophile substitution. They do the azide formation. This azide formation again under high temperature, it will give the indazole formation. And also when the extreme condition, the here can apply the very high temperature. You can see the in water, you can apply the 150 degrees Celsius. You will get within 2 minutes. We will get the product, and the intermediate one again we inserting benzohydrol, we get the final product monohydrol very short time. Within the 0.1 hours we get a 77% yield. And the summary continuous flow process enable the precise control over the reaction conditioning, improving the safety and reproduce. It improves the heat mass transfer, lead to higher yield, selectivity, and faster reaction time. Also, it use the reduce the solvent use, minimum energy and waste, and minimum waste generation to support the green chemistry principle. And the flow chemistry are technologies are safer and handling hazardous reagent and scalable, and now recent in India, many industries they are adopted in the flow chemistry, and they are seeking to the flow chemistry expert. And last, I thanks the organizing committee. They are invited me as the speaker. And also I thanks my the postdoctoral supervisor, Prof. Saif Khan, and my PhD supervisor, Dr. Ajay Kesing. Thank you.
Wankhede sir.
Thank you, Dr. Answer. Hello, I am audible.
Yeah, sorry.
Thank you, Dr. Answer. Now the session is open for queries of the participants. Participants are
Okay.
requested to ask some queries if they have.
Okay.
May I?
Yeah.
Yeah. Nice to see you after a long time, Nanisha.
Yeah.
I just want to know, you gave me the brief flow chemistry and introduction, and it's very nice. I just want to know about the what you just said about the pro of the flow chemistry. What about the cons? Like, what about the drawbacks? Like, because some reactions are like, whilst it's getting some precipitation and some other uh, problems. So how to deal with that?
Because pronon cause everywhere, but in the precipitate formation now the various slurry reactor pump also available, and according to which in the chemical now we are continuously developing that manner. So we are now developing new kind of reactor also for the flow chemistry for the slurry reaction, and for the like crystallization also we are continuously crystallization also performing. That time also precipitation is happened. So
Mm-hmm.
so we are in our current lab we are doing the same kind of reaction. So we are solving that one. We are getting the very good kind of crystal in the continuous flow.
And what about the like we can use this? We could use only PTFA and stainless steel flow reactors, right?
No. For the any, you can see the for the high acidic for the hydrochloric acid and H2SO4, we instead of stainless steel, we can use the Histloy also material and
Okay.
PFA, PTFE. Yeah.
Oh, is that okay? That's good. Mhm. And actually, I also have some other questions regarding the chemistry. I don't know. You said about some phthalimide. So I didn't get about this endoperoxide is formed and this how what is the endoperoxide how this endoperoxide get open? What is the driving force? I don't know this slide number something 10 or 12. I not remember
Just take
because
one minute.
it's like in singlet oxygen. You're getting with you're using the oxygen.
Just 1 minute. I'll get the slide.
Is the 16.
Yeah.
Yeah. So it's forming endoperoxide. You mentioned that endoperoxide 3. So what is the driving
With,
force to get it to this endoperoxide is open?
because of this peroxide is not stable and it will uh, here actually
Because I saw some of the drugs that are stable with the endoperoxide. So I just want to
yeah, but
just curious what is the driving force to get this endoperoxide open?
because of here you can see the hydroxy group also here, and it will that hydroxy group is
Okay, it's like I'm donating
formed
and
again the
then so
ketone formation, and it form the peroxide at this methyl position, and then it will form the dehydration.
okay. Uh-huh. Get it. And that's and the last one more question like regarding the NBS you mentioned with the solar chemistry.
Yeah.
So uh, do you try this reaction without in the dark like just mix the your uh this toluene derivatives and the NBS in the solvent and in the dark and do you see any product formation?
uh, Room
Because
temperature we
it's
get with the
no
time in
because I saw I know this some of the reactions are that with NBS and this toluene type of derivative that can be performed at room temperature just mix with this together and it's happen. It's no need a light or as per my knowledge. Okay, but I don't
Uh,
know, so that's why I
no,
just
no,
because did you try
that
this control experiment?
we try with the room temperature and in the dark, but we get only little bit formation of this product, but we required otherwise the initiator then we form the this one product with the we required around 50-60 degrees Celsius temperature. Then we will get the
Mhm.
product. Yeah.
Okay, and the last question regarding the CO2 emission from the vehicle exhaust you took it. Because in the vehicle exhaust, we didn't see any like only carbon dioxide. We see the nitrogen gas, unreacted fuel burn, plus sulfur dioxide and some nitrous oxide, carbon monoxide. So do you see any side product there in the formation? Because
What
you
is that?
see, you mentioned the products with the CO2 reaction you took from the vehicle exhaust.
Yeah, yeah, yeah. But we get the this uh, uh, because oxygen due to oxygen and we get the here three byproduct
Right?
finish. This
Because
actually another
you
two
mentioned
byproduct. Yeah, but
because you
the
mentioned the
nitrogen
yield around the 50%, so that's why I'm just curious a little bit because this
actually
whatever the
just I will open that
how
slide.
is that one is that I think
Yeah,
yeah.
yeah, yeah,
Hmm.
yeah. So here we try the reaction with the pure CO2 and oxygen and the carbon monoxide also. So
Mm-hmm.
carbon monoxide we can't identify whatever the form product, but the three product form whatever you can see this one. So carbon
Uh-huh.
the reaction with the carbon dioxide is very fast as compared to oxygen. So
Mm-hmm.
therefore the mostly first form the higher carbon dioxide and then phthalate and we will get this quinone also some byproducts because of over oxidation or some other factor. I don't know what exact going on there, but we'll get that one also some amount.
Mm-hmm. And you didn't see like any with the nitrous oxide or anything?
Uh, I want to try see this kind of that one. We just
Mm-hmm.
optimize the according to whatever we get the major one.
Mm-hmm. Okay, okay. Yeah, nice work. Thank you.
Thank you.
Is there any question from the participants? Okay. Dr. Answer, you have really expressed the topic in very good manner and in easy words. You have explained all details for flow chemistry. You have chosen the very important topic, sustainable chemical synthesis is the need of today. Hence, various technologies are invented and adopted. One of the technology is continuous flow technology. It enhances sustainable chemical synthesis by pumping reactants through narrow tubes, offering superior heat mass transfer, improved safety for hazardous reactions. It facilitates high throughput, efficient, and precise control over reaction conditions compared to traditional batch methods. This approach lowers E factor, that is, waste to product ratio, and enables faster, more reproducible products. I think the key aspects are enhanced safety, improved efficiency and reduce waste, energy efficiency, reduce solvent use, enabling green technology, small scale synthesis. Continuous flow is particularly valuable for the pharmaceutical and fine chemical industries. Once again, I am very much thankful to Dr. Answer for giving very informative talk on such an important technology on this platform. Finally, I am thankful to organizers for giving me the opportunity to chair such a nice session. On the behalf of organizers, I am thankful to everyone associated with this session. Finally, I am thankful. Thank you very much. And I declare that this technical session 2 is over and I hand over this part to the organizers. Thank you very much. Thank you.
Thank you, sir.
Thank you, sir. Sir, I'm audible. Wankhede, sir.
Yeah, you are audible.
Yeah, thank you. Yes, being a part of organizing committee, I'm very much thankful to our chairperson of this session, Professor Dr. R.R. Wankhede, Head Department of Chemistry, BP Science College, Digress, for chairing the session, as well as the resource person of this session, Dr. Dhaneshwar. Sir has shared his valuable research experience with all of us. Sir has given new ideas in our mind regarding this new research, and we are very thankful to him. Sir has given our valuable time and expertise to our audience also. I am also thankful to Dr. Tawfiq sir. Sir has also given very valuable time. Sir has interacted in this session, and sir has actually fulfilled the motto of this conference, because our motto is to the interaction, so that we have the new knowledge, or we can clarify our doubts. So actually the purpose of this conference is fulfilled during this session. So I am very glad here. And yes, because of this interaction, we have cleared so many doubts in our mind. And through the questioning of Tawfiq sir, I'm very much thankful to him. Once again, I'm thankful to Dr. Dhaneshwar sir, Dr. Tawfiq sir, as well as chairperson of this session, Professor Dr. R.R. Wankhede sir. Thank you, everyone.
Thank you. Thank you, ma'am. Thank you, respected resource persons and the chairpersons of both the sessions. Now we will continue with the third session of this international conference, which is the oral and poster presentation. For the oral and poster presentation, we have the respected jury members, Dr. C.D. Badnakhe, Associate Professor, Dr. Manorma, and Professor H.S. Punkar, Arts, Science, Commerce College from Badapur. Have you joined the session, ma'am? Okay. The second jury member, Dr. Sangram Raghuvanshi, BOS Chairman, Sant Gadge Baba, Amravati University, Amravati, from the Faculty of Commerce and Management. And the third jury member, Dr. Gopal Dhole, Dr. Gopal Rao Khedkar Mahavidyalay, Gadegaon, Telhara. We are honored to have such jury members for the oral and poster presentation. All the participants who are interested in oral and poster presentation are requested to kindly be ready with their sequence, and you are requested to raise your hand so that we can unmute from here. Now, on behalf of organizing committee, I welcome all the jury members, Dr. Badnakhe ma'am, Dr. Raghuvanshi sir, and Dr. Dhole sir. Now, I hand over the session to Dr. Badnakhe ma'am. Ma'am, please unmute yourself. Hello. Ma'am, you are not audible. Ma'am, you are unmute. Hello. Hello, Badnaki ma'am.
Hello, Dr. Badnaki ma'am. We are not able to hear you. Please unmute yourself.
Ma'am, please rejoin the session. Within few minutes, we are continuing the oral and poster presentation. Till then, I request all the participants, please be ready with your presentation. I request Dr. Dhule sir to please continue with the session. Sir, you are the co-host. Yes, sir, you are audible. Hello. Yes, Badnaki ma'am. Hello.
Hello.
Yes, sir.
Can I audible, madam?
Yes, sir.
Thank you very much.
Sir, there is a problem of echo. I think 2 meetings are ongoing there.
Yes, yes. Thank you. मुंगसाजी महाराज महाविद्यालय दारवा, डिस्ट्रिक्ट यवतमाळ.
Sorry to interrupt, sir. Your camera is off.
Thank you. Okay. Okay, madam.
Okay, sir.
Thank you. मुंगसाजी महाराज दारवा महाविद्यालय, मुंगसाजी महाराज महाविद्यालय दारवा, डिस्ट्रिक्ट यवतमाळ. International conference, interdisciplinary conference on material science and knowledge convergence. इंटरनॅशनल कॉन्फरन्स मध्ये आपण सर्वांनी सहभाग घेतला आणि या कॉन्फरन्सचे आयोजक तथा महाविद्यालयाचे अध्यक्ष आणि प्रिन्सिपल आणि आपण सर्व आयोजक मंडळी यांनी चांगल्या प्रकारे ही कॉन्फरन्स आयोजित केली. मी मागच्या सेशनला जॉईंट होतो आणि या सेशनमध्ये चांगल्या प्रकारे इंटरॅक्शन झालं. आपलं प्रेझेंटेशन सुद्धा खूप चांगल्या प्रकारे इथं मांडण्यात आलं आणि बाहेरच्या देशातील सुद्धा गेस्ट या ठिकाणी जॉईन झालेत आणि त्यांनी सुद्धा चांगल्या पद्धतीनं इथं प्रेझेंटेशन केलं. प्रश्नोत्तरं चांगली झाली आणि नॉलेजचं इंटरॅक्शन जे आहे ते व्यवस्थितरित्या आणि खूप सुंदर रीतीनं इथं प्रेझेंट केलेलं आहे. त्याबद्दल मी आयोजकांचे या ठिकाणी आभार मानतो आणि कौतुक सुद्धा करतो. तर पोस्टर प्रेझेंटेशन मध्ये आपण हे जे सेशन घेतलंय ते याच्यामध्ये पोस्टर प्रेझेंटेशन आपण करणार आहोत. तर या ठिकाणी मी सर्व मान्यवरांचे अभिनंदन करतो की त्यांनी चांगल्या पद्धतीने हे सर्व आयोजन केलेलं आहे. थँक्यू व्हेरी मच.
Thank you, sir, for your inspiring words. Hello.
Hello.
Padnaki ma'am. Please unmute yourself. Hello. Now I invite Dr. Sangram Raghuvanshi sir to please share their few words with us.
Hello.
Yes, sir.
Good afternoon to all of you. First, I have to congratulate the organizers of this international seminar. Basically, this is the subject. I am not the science person. I am from a commerce graduate. That's why ma'am, I am ठीक आहे. मी मॅडमला सांगितलं होतं की थोडासा माझा डेंटल इम्प्लांटचा प्रॉब्लेम होता, त्याच्यामुळे ठीक आहे. मी आता याच्यापूर्वीचा पूर्ण सेशन ऐकला आहे. डॉक्टर आनंद सरांचं अतिशय उत्कृष्ट असं मार्गदर्शन झालं. त्याच्यानंतर तौफिक सरांनी त्यांना खूप चांगल्या रीतीने प्रश्नोत्तर केले, जेणेकरून आपला जो उद्देश होता इंटरॅक्शनचा तो परिपूर्ण झाला असं मला वाटते. माझा ऍक्च्युली माझे जे सहकारी आहेत डॉक्टर ढवळे सर यांच्याशी झालेलं चर्चा. मॅडम माझा आवाज येतोय ना?
Hello.
हा,
Am I
आवाज येतोय?
audible now?
Yes, ma'am. Yes, Patnaki ma'am.
आवाज
You are audible.
Okay, okay. Now I can conduct the session if you permit me.
ओके ओके. मी
Okay, ma'am.
शुभेच्छा
Yes.
देतो. थँक्यू.
Yes, Raghuvanshi sir.
हा, मी तुमच्या इंटरनॅशनल कॉन्फरन्स शुभेच्छा देतो आणि
Yes,
मला
ma'am.
तुमच्या
May
बोलवल्याबद्दल धन्यवाद
may
देतो.
start the session.
थँक्यू.
Thank
येस
you.
मॅम,
Thank you,
प्लीज
sir.
कंटिन्यू. प्लीज कंटिन्यू मॅम.
Ma'am, Patnaki ma'am, please proceed with the session. Thank you.
Okay, okay. I am very sorry for this internet connectivity problem. So, a very good afternoon to all. All respected dignitaries on and off the dais attend this conference, today's session online as well as offline, of auspicious moments and events. I am Dr. C.D. Badnake, Department of Chemistry, Dr. Manorama and Professor H.S. Punkar, Arts, Commerce and Science College, Balapur, District Akola. I am very much excited and blessed in this session of oral as well as poster presentation of International Interdisciplinary Conference on the Material Science and Knowledge Convergence. Recent Advances for Sustainable Development, MSAC 2026. Let me acknowledge first my gratitude to President of the institution, Secretary.
Hello. Ma'am, your voice is not clear. It is breaking. Hello, Badnaki ma'am.
Dr. Respected Dr. Sangeeta Guikedkar, Madam, Vice President, President of this Viraj Guikedkar sir, Principal of the college, Dr. Chakve sir, Vice Principal, Dr. Bageshwar sir, Head of the Department, Chemistry Department, Dr. Nazia Rashidi Madam, Dr. Bhagwat sir, Dr. Neha ma'am, and all the arranging committee of this conference, that is MSKC 2026. Now it's my very pleasurable moment for me that you have handed over this technical session to me as a jury for this oral and poster presentation. So I would like to make you familiar, all the participants, with some of the rules. Listen carefully. You have been provided 10 minutes for the whole presentation. Out of that, 8 minutes for your presentation of the material, script, and 2 minutes for the interaction. Now there is evaluation criteria that will carry the marks: originality and novelty, 15 marks; scientific academic content quality, 20 marks; clarity of the subjects and relevance, 10 marks; organization and structure of the script, 10 marks; presentation skill, it will carry more marks, 15 marks. If you are using the PPT poster on some of the teaching aids, then it will carry the 10 marks. Time management is very important for this, and that is carrying the 5 marks. Response to the question, that is the interaction section, understanding, critical thinking, and ability to defend the research, it will carry 10 marks. So in this way, the whole marks will be attributed, it will be given to all the participants. So with the kind permission of this arranging committee of this today's conference and the oral and poster presentation session, I would like to start this. So Dr. Nazia ma'am, may I start it? Dr. Neha ma'am, am I audible?
Yes, yes. Yes, ma'am, you are audible.
Yes, yes. So I would like to enlist and the names I will read one by one. Neha Srivastav, DA College, Dehradun, Department of Botany. She is for the oral presentation. Is this Naina Srivastav today? She is present online or offline?
Hello, Naina Srivastav. Ma'am, she will be joining the session online.
Yes, no problem. Doesn't matter. But is has she joined the online platform also?
Let me check.
Naina Srivastav.
No, ma'am. In the participant list,
She's
I'm
from
not
the
finding her.
subject botany.
Naina. नहीं, joining में नहीं है.
Neha ma'am, is she present in the online platform?
No, ma'am.
Okay, so proceed for the next. Miss
Proceed for the
Tejaswini Lagsane. She's from the management department. Oral presentation. Is she present?
I request the participants to please raise your hands.
Yes, that will be convenient for us.
Ma'am, Tejaswini is also not there.
Okay. So let us move the next. Prajakta Motilal Gulalkari. Prajakta Motilal Gulalkari from Rammeghe College of Engineering Management, Badnera. Is she there? Has she joined the session?
No, ma'am, she is not in the participant list.
I have got her name.
We should proceed with the next.
Kalur Subramaniam from the Department of Physics. Has he joined his session?
No, ma'am.
Kalur, okay. Rushikesh Shivaji Sanap, Department of Chemistry. Rushikesh Shivaji Sanap. Neha
It's a
ma'am,
humble request to all the participants. Kindly be present as per the serial numbers given in the list. It will be convenient for us for the presentation. And after taking the names, I request the participant to kindly raise your hands so that our time will not be killed. Thank you.
Has he joined Rishikesh Shivaji Sanap?
No, ma'am, I'm not able to
Okay.
find him.
Let us move for the next. Archana S. Navle. I think she has raised her hand
Yes,
just
yes.
now. Okay, Archana, you can start your
Archana.
presentation. Okay. Start your session.
Yes, you can share the screen now.
कंटिन्यू चालू कर हे दिसते नेक्स्ट बस इथे.
Your screen is visible. You can start.
Good afternoon, respected chairperson. Myself, Miss Archana Subhash Navle. I am pleased to present my research work entitled Synthesis, Characterization, and Biological Evolution of Erlobitin Link 123 Triazole under the guidance of Dr. K. F. Sharke sir, Department of Chemistry, late Pushpadevi Patel, Arts and Science College, Resort. This is second slide.
Now.
Introduction. Heterocyclic chemistry is the most important branch of organic chemistry. Two-thirds of organic compound in the universe are heterocyclic compound. From the ring, at least one carbon atom replaced by other atom like nitrogen, oxygen, or sulfur, etc. are referred to as heterocyclic compound. Heterocycles are classified into 4 types. First one is 3-member heterocycle, 4-member heterocycle, 5-member heterocycle, and 6-member heterocycle. Triazoles. Triazoles are 2 types. First one is 1,2,3 triazole and 1,2,4 triazoles. Now my work on this reaction 1,2,3 triazole. First reaction, it is the old method for the preparation of triazoles. That is azide plus alkyne. In presence of it, formation of 1,2,3 triazoles. But nowadays this is synthesis on my work on new work. This is click reaction. Synthesis, the compound were synthesized using the click chemistry approach, specifically the copper sulfate catalyze azide alkyne cycloaddition reaction. This is the biological importance of 1,2,3 triazoles. Biological activity, this is the antimicrobial activity, antiviral activity, anti-inflammatory activity, anti-lasmatic activity, anti-tryptonosmal activity, anti-diabetic activity, anti-cancer activity, anti-toxidant activity, anti-tuberculosis activity. Present research work. I have synthesized 7 erlobitin drug link 1,2,3 triazoles by using click chemistry approach. Also characterized by 1H and 13 NMR spectra and HRMS and evaluated antimicrobial activity as well as molecular docking study. Against INAH bacterial protein, So now these are synthetic method. Firstly, I have prepared different substituted seven azido benzotization method. Now we react this substituted azidobenzene with the erlobitin to form different erlobitin link 1 to 3 triazole derivatives by click approach in present of catalytic amount of copper sulfate and sodium ascorbate in PEG 400 solvent at room temperature. We got 80 to 92 yield of different erlobitin link 1 to 3 triazole derivatives. These are the derivatives: four substituted nitro, 1,2,3 triazole, four para substituted fluoro, 2 bromo, and 4 bromo, 2 chloro, 2 methoxy. These are the antimicrobial activity of 1,2,3 triazole derivatives. These are the zones. Entry, and these are the entries and pathogens. These are the various types of zone. And docking study, molecular docking study revealed that all the bioactive erlobitin 1 to 3 triazole derivative could recognize the binding site of INAHA and got deeply embedded in it, engaging in a network of bonded and non-bonded interaction. They have produced an average docking score, glide score of minus 8.031 with an average binding energy, guild energy of minus 50.051 kilocalorie per mole, signifying a promising binding affinity towards the target. And thank you.
Thank you.
अनम्यूट नहीं हुए थे हेलो
Hello.
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 Yes.
Now the topic is open for discussion. You may ask the questions to the participant. If anybody has query regarding the topic. Nobody has a query? From the participants, anybody has the query, you can share your query with the participant who has conducted her speech now. Archana.
Hello, am I audible?
Yes, yes, sir. You may ask.
Ma'am, the microbial activities antimicrobial activities of the triazole was analyzed by self or outsourced?
Outsource at RA College.
ऍक्टिव्हिटीज कशा चेक केलेल्या आउटसोर्सिंग केलेलं आहे की स्वतः केलेलं आहे?
Outsource.
Am I audible?
Yes.
Yes, sir, you are audible. Miss Archana, can you answer?
Outsource of RA College, Washim.
Am I audible?
Yes, yes.
Yes, sir. Yes. Okay. May I move to the next participant? Neha ma'am.
Yes, ma'am. Hello.
आता काही जॉईन व्हायचं नाही. इथं म्यूट करतो. इथं व्हिडिओ स्टॉप.
Next participant.
Yes, the next Neha ma'am.
Yes, ma'am.
हमारी आवाज आ रही है आपको? Okay.
Yes, yes, you
So
are
the
audible.
next participant is Dr. Kamalakar Kailash Vawad. Has he joined the session? Banmeru Science College, Lonar. Dr. Kamalakar Vawad. Okay.
No,
I
ma'am.
think
He
he is
has
not
not
present
joined
in
the
the
session.
Okay, okay. Dr. Naveen Dattatray Zambekar from the Department of Computer Science.
He is also
Gopikabai
not there,
Sitaram.
ma'am.
Okay. Then the next participant is Shrikant Mahadevrao Dhupe from Commerce Department. SSR Bharati Science College, Arani. Has he joined the session?
No, ma'am. No, he is not in the list.
Okay. The next participant is Abhay Mahesh Taide, RDIK and NKD College, Badnera, from the Department of Statistics.
Yes, he is there. Mr. Abhay, please raise your hand.
Mr. Abhay Taide, have you joined the session?
Yes, ma'am. He is in the list.
Okay, so let him be permitted for join presentation.
Abhay Taide.
Abhay Mahesh Taide from RDIK Science College, Badnera.
Yes. Mr. Abhay Taide, kindly unmute yourself and please present the PPT. Hello.
Mr. Abhay Mahesh Taide.
Are you there, Mr. Taide? I think he has joined from another device.
Whatever it may be.
Abhay, by
Let
the
him be
name Abhay.
permitted for the presentation.
Yes, yes, ma'am.
Yes, he has joined the session now. Mr. Abhay, you can proceed.
Hello. Mr. Abhay, you are not audible. Kindly unmute yourself. आवाज नहीं है.
He has started sharing the screen, but not visible yet. Yes, now it is visible. Abhay, you may proceed.
I request the next participant kindly raise your hand.
Mr. Abhay Mahesh Taide.
Hello, Mr. Abhay. Please share your presentation and start the presentation. Hello, ma'am. I think he is facing some problem. Can we proceed with the next participant?
Yes,
I
ma'am.
think Pooja
Dr.
Akode
Ashwin
has raised her hand.
Prabhakar Dr. Ashwin Prabhakar Rao Paskavade, Department of Physics. Has he joined the session? Dr. Ashwin Paskavade. Neha ma'am?
Hello, ma'am. Hello.
Who is talking?
Yeah, ma'am. Abhay Tade.
Okay. बोला सर.
मॅम ते स्क्रीन शेअर करताना थोडा प्रॉब्लेम होत आहे पीपीटी मध्ये.
Okay. Take your own time, sir. Let us move to the next participant. Dr. Ashwin Prabhakar Rao Paskavade.
He has not joined the session, ma'am.
Dr. Ashwin has joined the session, ma'am. Neha ma'am.
No, ma'am.
No, okay. So let us move to the next participant, Chandrakant Dhanwad. Chandrakant Dhanwad.
He is also not there, ma'am.
Okay. Dr. Rajesh Mahadev Rao Bharate. Has he joined the session?
No, he is also not there, ma'am.
Okay. Sanjay Ambadas Salve.
Hello, madam.
Jizamata Buldhana. Have you joined the session? Sanjay Ambadas Salve. Have you joined the session?
No, ma'am. Mr. Sadve is also not there.
Okay. So let us switch on the next participant, Sayyid Samif-Uddin Sayyid Riazuddin from Government Vidarbha Institute of Science and Humanities, Amravati. Has he joined the session?
Sayyid. No, ma'am.
Okay. Let us switch on the next participant, Dr. Gaurav Dhaneshwar Kale, Department of Physics, Sri Vitthal Rukmini Arts Commerce Science College, Savna. Has he joined the session either online or offline? Neha ma'am?
No, ma'am.
Okay. Shubham Manohar Singh Tungade. Shubham Manohar Singh Tungade.
No, ma'am.
Okay.
He is not in the session.
Prachi Sunil Gaun. SSSKR Inani College Karanjalad. Department of Physics.
No,
So for the poster
she is
presentation,
also
I think
not there,
let us
ma'am.
concentrate on the first and the oral. Okay. मिस तनया मांजरे, विद्या भारती महाविद्यालय अमरावती, डिपार्टमेंट ऑफ मैथमेटिक्स. Has he joined?
No, ma'am. She is also not there.
Okay. Ramesh S. Chavan, BP Science College, Digras, Department of Chemistry.
My name is
Ramesh S. Chavan, BP Science College, Digras. Has he joined the session? Department of Chemistry.
ma'am. Mr. Abhay has shared his screen.
Okay, okay. Let us give him chance for the presentation. Mr. Abhay, you may proceed now.
You are not audible, Mr. Abhay. Kindly unmute yourself.
Mr. Abhay.
हेलो, आवाज आ रही क्या मैम?
Yes, yes, you are audible.
हाँ, sir.
Yes,
You may
ma'am.
proceed now.
Yes,
Start
ma'am.
your
मैम
presentation.
शेयर स्क्रीन हो रही?
हाँ जी, हो रही है. आप स्टार्ट
Okay,
कर
okay.
सकते हो अपना
Okay,
प्रेजेंटेशन.
okay. Thank you, ma'am. Good afternoon, respected chairperson, distinguished guests, and fellow researchers. My name is Abhay Mahesh Tade from Barrister RDAK and NKD College Badnera, and today I am honored to present my research title, A Statistical Study of Knowledge Convergence in Material Science and Sustainability. आज के समय में सस्टेनेबिलिटी सिर्फ एक एकेडमिक टॉपिक नहीं है, बल्कि एक ग्लोबल रिस्पॉन्सिबिलिटी बन चुकी है. हेलो, आवाज आ रही है मैम?
हाँ सर, आ रही.
हेलो.
यू मे प्रोसीड नाउ. हाँ सर, आ रही है
हेलो.
आपकी आवाज. हेलो.
हेलो.
You are audible, sir. You may proceed
हेलो.
now. Hello.
हेलो.
You are audible,
Hello, ma'am.
Mr. Abhay. Kindly proceed.
हाँ मैम. मैम आवाज आ रही?
Yes.
हेलो. ओके. आज के समय में सस्टेनेबिलिटी सिर्फ एक एकेडमिक टॉपिक नहीं है, बल्कि एक ग्लोबल रिस्पॉन्सिबिलिटी बन चुकी है. क्लाइमेट चेंज, एनवायरमेंटल पोल्यूशन और नेचुरल रिसोर्स की कमी, यह सब हमारे सामने सीरियस चैलेंजेस के रूप में खड़े हैं. इस कंटेक्स्ट में मटेरियल साइंस का रोल बहुत इंपॉर्टेंट हो जाता है. मटेरियल साइंस हमें एडवांस, ड्यूरेबल और इको फ्रेंडली मटेरियल्स डेवलप करने में मदद करता है. जब मटेरियल साइंस और सस्टेनेबिलिटी एक साथ इंटीग्रेट होते हैं, तब हम एक पावरफुल कंसेप्ट देखते हैं जिसका नाम है नॉलेज कन्वर्जेंस. नॉलेज कन्वर्जेंस का मतलब है डिफरेंट डिसिप्लिन्स का एक साथ आकर कॉम्प्लेक्स प्रॉब्लम को सॉल्व करना. इंडिया में पिछले कुछ सालों में इंटरडिसिप्लिनरी रिसर्च में नोटिसेबल ग्रोथ देखी गई है, स्पेशली मटेरियल साइंस और सस्टेनेबिलिटी के बीच. मेरी रिसर्च इसी ग्रोइंग इंटीग्रेशन को स्टैटिस्टिकली एनालाइज करती है. ऑब्जेक्टिव्स ऑफ द स्टडी. इस स्टडी के 5 मेन ऑब्जेक्टिव है. फर्स्ट मेन ऑब्जेक्टिव, इंडिया में इंटरडिसिप्लिनरी रिसर्च की ग्रोथ को स्टडी करना. सेकंड, मटेरियल साइंस और सस्टेनेबिलिटी के बीच नॉलेज कन्वर्जेंस को स्टैटिस्टिक्स टूल्स से एनालाइज करना. थर्ड, रिसर्च पब्लिकेशन और कोलैबोरेशन के ट्रेंड्स को आइडेंटिफाई करना. फोर्थ, इंटीग्रेटेड रिसर्च का कंट्रीब्यूशन सस्टेनेबल डेवलपमेंट गोल्स की तरफ इवेल्यूएट करना. और फिफ्थ, सबसे इंपॉर्टेंट, रिसर्चर और पॉलिसी मेकर्स के लिए एविडेंस बेस्ड इनसाइट्स प्रोवाइड करना. सिंपल शब्दों में यह स्टडी यह समझने की कोशिश करती है कि कैसे अलग अलग डिसिप्लिन्स मिलकर सस्टेनेबिलिटी को एक स्ट्रेंथन कर रही है।
Mr. Abhay, I think there is some technical issue on your side. Yes, Neha ma'am.
Yes, ma'am.
I think there is some technical issue in his presentation. That's why it is interrupted. Isn't it?
Yes, ma'am. Actually, I think the next
Okay.
participant kindly
Ms.
raise your
Tanaya
hand.
Manzre, Department of Mathematics, Vidya. Is she present in the Pendal online or offline?
No, ma'am. Miss Tanaya is not present in the session.
Okay, then the Ramesh S. Chauhan, BSP Science College, Digres, Department of Chemistry. Has he joined the session?
No, ma'am. Mr. Syed has joined the
Okay.
session. Syed Samyuddin.
Acha, from Vidarbh Mahavidyalaya, Amravati. I think
Yes.
Syed Saimuddin. Okay. Mr. Syed
Hello, madam.
Samyuddin, Syed Riyazuddin.
I am
Yes, you
audible
are
to
Have
you.
you joined the session?
I am audible to you.
Yes, you
Yes.
are audible. Yes, sir, you are audible. Mr. Syed Samyuddin, sir, you are audible. You may start your
Yes, madam.
presentation now.
Yes, madam.
Okay.
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 I
Start. You may share your slides now.
Hello, Mr. Syed. Kindly unmute yourself and please proceed for the presentation.
okay. I am audible to you.
Yes, you are audible.
Yes,
Kindly
sir, you
start
are
the
audible.
presentation.
Okay, okay, okay.
Please share your slides.
Ma'am, there is some problem occurring in the opening of slides.
Okay. Slide. Are you not able to share the screen?
So,
Ma'am, some problem occurring in the opening of my slides.
Okay.
okay. Try later on. We will
Okay,
switch on
ma'am.
the next candidate.
Okay, ma'am.
Jnaneshwar Prakash Rathod, Adarsh Mahavidyalay, Dhamangaon, Department of Mathematics. Mr. Jnaneshwar Prakash Rathod. Has he joined the session?
No, ma'am.
If the participant has joined the session, I would like to request them to raise their hands. So it will be convenient for us.
Pooja Akode. Ma'am, Pooja Akode
Okay.
is there.
Vaishnavi Gajanan Memani. Vaishnavi Gajanan Nemane, MSc and KPT College, Manora, Department of Chemistry. Has she joined the session?
Hello.
Miss Vaishnavi Gajanan Nemane. हाँ मैडम. नेहा मैडम.
No, ma'am. Miss Vaishnavi is not there.
Okay. Pankaj S. Chaudhary.
Sorry to interrupt, ma'am, but Pooja Akode is there and she is ready with her presentation.
Okay.
Ma'am,
Let her
मेरी
start.
slide दिख रही
Pooja
है आपको?
Akode. Yes, what the
Ma'am, मेरी
problem you are
slide दिख रही
facing,
है
Miss Pooja? Slide visible नहीं हो रही.
मेरी slide है आपको?
नहीं दिख नहीं रही अभी तक. It is not visible on the screen. Miss Pooja.
Yes, ma'am. Wait, some I have.
Okay, take your own time. Again, I would like to request to all the participants, if they have joined the session in either online or offline manner, please raise your hand when your names are being read. Okay? So it will be convenient for us to conduct the session. Thank you.
Is this visible, ma'am?
No, you are not
Hello?
audible in a clear way. Yes, ma'am. Yes, Pooja, ma'am.
Is this visible or not?
No, not yet. Not yet.
Okay, wait some time. Okay, ma'am. I have. I have facing some issues, ma'am. Please carry on next person, okay?
Okay. So Pooja ma'am, may I read the next participant's name?
Yes. Can I only read my paper?
You have to take the permission of the convener of this conference, actually, Dr. Nazia ma'am. Okay. Please kindly ask her, take her permission and then start.
Okay, no problem.
Pooja. Hello, Pooja ma'am.
Yes, ma'am.
Not ready.
Ma'am, my file are not open this screen, so I have faces some issues. So I have only read my paper.
Later on, we give you one more chance because reading the paper
Okay, no problem.
not be like a presentation. and it will not be committed.
Okay. Okay, no problem, ma'am. Please continue next person.
Okay. Pooja ma'am, Neha ma'am, may I read the next participant's name? Neha ma'am.
Yes, ma'am.
Yes, ma'am. Please continue.
Pankaj S. Chaudhary, Sri Vitthal Rukmini Arts, Commerce and Science College, Savna, Department of Chemistry, for poster presentation.
He has not joined the session, ma'am.
Okay. Then Miss Rakhi Dhaneshwar Bankar, Shivaji Science College, Amravati. Miss
She is
Rakhi
also not
Dhaneshwar
there.
Bankar. Okay. Giridhar Pandurang Save, Janata Mahavidyalay, Chandrapur, Physics Department. Giridhar Pandurang Save.
No, ma'am. He is not in the session.
Miss Suchita Gajanan Mane, VN Arts Commerce Science College, Mangrur Pir.
No, ma'am.
Miss Prachi Totaram Sarkate, Shankarlal Khandelwal College of Arts and Commerce Science, Department of Chemistry.
No, ma'am. She has also not joined the session.
Dr. Nilesh V. Rathod, RA Arts, Commerce Science College, Washim, Department of Chemistry.
No, ma'am.
Has he joined?
Hello, ma'am.
Okay.
Hello.
Yes, Dr.
Hello, ma'am.
Nilesh, are you there? Yes, sir.
No, ma'am. Abhay
Yes,
Tade,
sir.
ma'am.
Abhay, Mr. Abhay.
मैम थोड़ा
Okay.
सा नेटवर्क के
Yes,
प्रॉब्लम की
Abhay,
वजह
there,
से
sir.
बीच में ही हो गया मैम.
So can you proceed now for the
Hello,
next
ma'am.
slide? Yes, Mr. Abhay,
Yes, ma'am.
can you proceed for the? Okay, start yourself.
Okay, ma'am. One
Mr.
second,
Abhay,
sir.
start.
Okay.
Okay. I think we have moved to the second or third slide.
Yes, ma'am. Yes. हेलो मैम. मैम स्लाइड दिख रही मेरी?
Yes, sir.
स्लाइड दिख रही
No,
मैम?
you are no, not visible yet.
हेलो मैम. One second.
Your slide is not visible.
Ma'am, 1 second only. Ma'am,
Yes,
give me 1 second.
Okay.
हेलो मैम. हेलो. हाँ मैम.
Yes, you are audible.
यस मैम. मैम स्क्रीन दिख रही है मैम?
Yes.
Yes, sir. Now it is visible.
मैम स्क्रीन इज विजिबल?
Yes, sir.
Yes, sir.
ओके. तो मैम ऑब्जेक्टिव्स ऑफ द स्टडी फर्स्ट टू.
Yes,
इस
yes.
स्टडी के 5 मेन ऑब्जेक्टिव है. फर्स्ट, इंडिया में इंटरडिसिप्लिनरी रिसर्च की ग्रोथ को स्टडी करना. मटेरियल साइंस और सस्टेनेबिलिटी के
Hello.
बीच. Yes, ma'am.
Sorry to interrupt. Your PPT is not visible, sir. Only the screen is visible. Chat box
PPT
is
not
there.
Screen
Telegram
is not
is
visible.
open.
Screen of the presentation.
मैम अभी विजिबल है?
No, sir.
What problem? Close to now.
Hello, Mr.
Yes,
Raghav,
sir.
kindly share your PPT in the chat box.
Yes, that will be convenient. And
so that we can share it
from their side. Isn't it, Neha ma'am?
Yes, ma'am.
Mr. Abhay, can
Kindly
you
share your
your
PPT in the chat box, those who
Okay.
are facing the problem.
They will run your PPT.
मैम अभी विजिबल है मैम?
No, sir, not yet.
Or mail at the given mail of the conference.
Problem.
I think Neha ma'am, can we proceed for the next participant?
Yes, ma'am.
Mr. Nilesh V. Rathod, has he joined the session? Dr. Nilesh V. Rathod.
No, ma'am.
Keshav Jnanoba Nirde. Keshav Jnanoba Nirde.
No,
Dr.
ma'am.
R.G. Rathod, RD, Arts, Commerce, Science College, Murtizapur. Nirde, sir, have you joined the session? Poonam Anandrav Patil. Poonam Anandrav Patil, Inani Mahavidyalay, Karanja Lad, Department of Botany.
She is also
Sajid Kausar Shah. Sajid Kausar Shah, GS Tompe College, Chandur Bazar. Department of Chemistry. Has he
Sajid
joined?
is also not there.
Okay. Professor D.Y. Taide, Fulsing Naik Mahavidyalay, Pusan, Computer Science Department.
No, ma'am.
Okay. Dr. Jaya Johan Check Parambil, RS Bidar College, Hinganghat, Physical Education.
No, ma'am. She is
Dr.
also
Jaya, Dr. Pooja Akode, I think she will deliver her presentation in the next time. मीनाक्षी वामन बोढेकर, श्रीमती साळुंकाबाई राऊत कला वाणिज्य महाविद्यालय वणोजा, Political Science.
Yes, Meenakshi
Has
Bodekar
she
is
joined
there.
this session? Okay.
Meenakshi
Yes,
Bodekar, kindly
Meenakshi,
raise
have you
your
joined
hand.
the session? Neha ma'am, I think ask them, request them to share their PPT on our mail, and we will run the PPT. So it will be convenient for them as well as for us also.
Okay, ma'am.
If it is, they
Madam?
are facing some technical issues. Yes, Meenakshi.
Hello.
हा मी
Meenakshi
present आहे,
Bodekar,
ma'am.
ma'am.
माझा आवाज येतोय मॅडम?
हा बोला ना. हो, अगदी छान येतोय तुमचा आवाज, बोला.
नमस्कार मॅडम, शुभ दुपार सगळ्यांना. माझं नाव आहे मीनाक्षी वामन बोढेकर. श्रीमती साळुंकाबाई राऊत कला व वाणिज्य महाविद्यालय वनोजा, तालुका मंगरुळपीर, जिल्हा वाशिम ची संशोधक विद्यार्थिनी मी आहे. आणि माझे संशोधन लेखाचे नाव आहे अंत्योदय समाजातील शेवटच्या घटकाचे मानवी हक्क आणि मूल्य एक अभ्यास. आवाज येतोय ना माझा मॅडम?
मॅडम तुमचा आवाज येतोय पण तुमच्या स्लाइड्स विजिबल नाही आहेत.
मॅडम मी
So
पीपीटी
may
नाही
I
बनवली
request you to start your presentation.
Hello. Meenakshi ma'am,
Okay.
yours.
ओरली प्रेझेंटेशन आहे मॅडम माझं.
You please take the permission of convener of this conference.
Ma'am.
Dr. Nazia ma'am, if she is permitting you, then you may proceed. Neha ma'am. Yes, ma'am. She's taking the permission for just reading the paper. She didn't made PPT. So she cannot run the PPT.
Oral presentation, but you have to show your slides.
Yeah, that is the rule. Meenakshi madam. Hello, Meenakshi madam. I think she has left.
मेरे रिएक्शन देखेंगे तो बोलेंगे आप लोग आर्ट्स वाले समझते
Meenakshi ma'am, are you there in the online pandal?
Meenakshi ma'am, you are on mute. Please reply. It's a humble request to all the participants on behalf of the organizing committee to kindly mail your presentations at the given email ID of the conference so that we can share from our side, and it will be convenient for all the participants as well as the jury members without killing time. So it's a humble request to please send your PPTs on the given mail ID. I am sharing the mail ID in the chat box. Kindly proceed fast. Thank you.
Ma'am, I have already shared for your email ID. Please check my file and open it. Gramin Sthanik Swarajya Sanstha.
Okay.
राष्ट्रसंत तुकडोजी महाराज नागपूर युनिव्हर्सिटी स्थानिक स्वराज्य संस्थेतील महिला सक्षमीकरण एक चिकित्सक आढावा.
Just give us 2 minutes. We will share the PPTs that we have received. Thank you. ये आप इसको लॉगिन कीजिए.
हाँ बच्चे बुला रहे तो ये बंद कर बच्चे बुला रहे नंबर signing.
Mr. Abhay Tade has raised his hand. I think he is ready for the presentation. So, can we provide him permission? Neha ma'am.
Yes, ma'am. Just give me 2 minutes.
Mr. Abhay.
Wankhede sir.
Neha ma'am.
Yes, ma'am. I am going to share the presentation of Miss Pooja Akode. Can we proceed with that?
Okay, okay.
Thank you.
Okay, yes, definitely. Go on.
Share करायचं.
I am visible.
No, not visible yet. The PPT, the screen is not visible, Miss Pooja.
Ma'am, I have already shared college website. So, sir, I think, sir, search for that.
Share this. Yes, we are sharing. Download. Okay. Is the screen visible?
Yes, ma'am.
Yes,
This
now
is my
it is visible.
paper.
Please kindly proceed.
Okay, carry on, carry on.
Namaskar. And thank you, ma'am. And especially thank you for that. Namaskar, all of you and committee member. I have participated my paper like स्थानिक स्वराज्य संस्थेतील महिला सक्षमीकरण एक चिकित्सक आढावा. माझ्या मार्गदर्शिका सौ नीता गबने मॅडम. शी इज गोपिकाबाई भोरे महिला महाविद्यालय तुमसर जिल्हा भंडारा. आय हॅव प्रेझेंट माय पेपर. सो राजकीय महिलेमध्ये महिला जशा असतात लाईक जशा ग्रामपंचायतच्या महिला असतात किंवा आपल्या जिल्हा परिषदच्या महिला असतात त्यांना कोणत्या कोणत्या फेसिंग कराव्या लागतात या सगळ्या गोष्टींमध्ये मी काही इथे प्रेझेंट करण्याचा प्रयत्न केलेला आहे. सारांशमध्ये मी इथे उल्लेख केलेला आहे 73 आणि 74 घटना दुरुस्तीमध्ये. जसे की आपल्याला माहिती आहे 73 नुसार आपल्याला 36 महिलांचा इथे आरक्षण भेटला होता आणि नंतर त्यांना 50% 50% करण्यात आलं. पण रिसेंटली सध्याही आता महिलांना तेवढं अधिकार नाही आहे. जसं मी महिलांना इंटरॅक्ट केलं लाईक जिल्हा परिषद महिला किंवा आपल्या ग्रामपंचायतच्या जेवढ्या पण महिला आहेत तर त्यांच्याकडून असं पाहायला भेटतो की जिल्हा परिषदची जी अध्यक्ष असते ती घेऊ शकते जर ती सुशिक्षित असली तर. इथे शिक्षणाचं एक मोठं मला काहीतरी एक मतभेद असे पाहण्यास भेटले की जिथे सुशिक्षित जर अध्यक्ष असली तर ती स्वतःचे निर्णय चांगले प्रॉम्प्टपणे घेऊ शकते आणि तिथेच जर अशिक्षित महिला असली तर तिला एक अधिकाऱ्याचा पण मतभेद तिथे पाहण्यात भेटतो आणि स्वतःचे डिसिजन घेण्यामध्ये थोडंसं तिला एक प्रॉम्प्ट नाही यूज करता येत असं मला या दृष्टीतून पाहायला भेटलं. जसं माझा PhDचा सब्जेक्ट पण तोच आहे आणि त्याच्यानंतर हळूहळू जशी जशी स्थिती आता होत आहे त्या हिशोबाने आता मी इथे माझ्या पेपरमध्ये प्रत्येक गोष्टी टाकलेल्या आहेत. जशा की आता जर मी एक महिलांच्या राजकीय क्षेत्रातील आरक्षणाचे आणि शासनाकडून सबलीकरण कार्यक्रम योग्य अंमलबजावणीमुळे पुरुष प्रधान जे समाज आहे महिलांना सुद्धा सामाजिक आणि आर्थिक दृष्ट्या समान अधिकार मिळालेले आहेत. जोड असल्यामुळे आमच्या महिलांमध्ये सामाजिक आणि आर्थिक धोरण निर्मिती प्रक्रियेत पूर्ण क्षमता सहभागी होता येत आहे का? आर्थिक दृष्ट्या सुद्धा आमच्या महिला स्वावलंबी आणि आत्मनिर्भर बनत आहे का? राजकीय आरक्षणामुळे बहुसंख्य महिलांना इच्छाशक्ती जोरावर त्यांचे होत असलेले राजकीय खच्चीकरण मोडीत काढले आहे का? अलीकडच्या काळामध्ये जसे आपण पाहत आहोत राजकीय दृष्ट्याची जर जाणीव आपण बघितली तर आरक्षणाच्या माध्यमातून राजकीय नेतृत्व करण्याची संधी त्यांना मिळालेली आहे का? असे काही मी प्रश्न त्यामध्ये टाकलेले होते आणि जसं आता लास्टली मला जर एक म्हणावं असेल तर कुटुंबाची त्यांना किती प्रमाणे सहभागीकरण भेटतो. जर त्या राजकीय क्षेत्रामध्ये उतरल्या तर त्यांना त्यांचा हातभार किंवा त्यांचं सोबत किती भेटते. 13व्या आणि 14व्या घटना दुरुस्तीनुसार जर आपण बघितल्या तर ग्रामपंचायत आणि ग्रामविकास इत्यादी बाबत निर्णय प्रक्रियेत सहभागी होत आलेल्या आहेत का? त्यांच्या वाढत्या सहभागामुळे महिलांना तेवढा प्रतिकार किंवा त्यांचा तेवढा एक प्रेझेंटेशन त्यामध्ये आपल्याला पाहण्या भेटतो का? किंवा कौटुंबिक समस्या यामध्ये सुद्धा त्यांचं एक मोठं आहे. जर राजनीतीमध्ये उतरले तर कौटुंबिक समस्या पण फार येतात. तर या सगळ्या गोष्टींचा मी एक आढावा इथे टाकण्याचा प्रयत्न केलेला आहे. काही पुस्तकं याच्यामध्ये मी टाकलेली आहेत, जसे पाटील सरांची आहेत. पंचायत राज संस्थेत महिलांचा सहभाग, प्रबोधन प्रकाश पुणे, गजानन वीरकर महिलांच्या राजकीय सक्षमीकरणात राजकीय राज्यांच्या भूमिका, गजेंद्र कदम यांचे भारतातील महिला सक्षमीकरणाचे धोरण आणि महिलांची अद्याप स्थिती, प्राध्यापक व्ही डोंगरे महिला राजकीय सक्षमीकरण जनरल ऑफ एशिया फॉर डेमोक्रॅटिक डेव्हलपमेंट, कैलाश सोनवणे यांचं महिला राजकीय आरक्षण धोरण आणि सक्षमीकरण, असे काही. आणि माझ्या ज्या गाईड आहेत त्यांची पण इथे पुस्तक प्रकाशित झालेली आहे. लोकशाही प्रक्रियेत महिलांचा राजकीय सहभाग किती आहे ते. आता एवढं मी यामध्ये आपल्या प्रतीनं टाकण्याचा प्रयत्न केलेला आहे. आणि सरकारचे हे कर्तव्य योग्य रीतीने पार पडत आहे की नाही हे एक उल्लेख यामध्ये केलेला आहे. मला पेपर प्रेझेंट करण्याचं इथे आपण अनुमती दिली त्याबद्दल सगळ्यांचे धन्यवाद. खास करून माझे पॉलिटिकल सायन्सचे प्राध्यापक सकवे सर आणि आपले प्रिन्सिपल. थँक्यू व्हेरी मच. थँक्यू ऑल ऑफ यू. थँक्यू नाझिया मॅम. थँक्यू ऑल कमिटी मेंबर्स.
Thank you. Now the topic is open for discussion. Among the participants, if somebody has the query, you may proceed for the query. Kind request to all the participants, if you have some query regarding her subject, you may ask now. जर कुणाला काही अडचण किंवा प्रश्न विचारायचे असतील तर आपण विचारू शकता. The topic is open for discussion now. Yes, anybody has the query, you may discuss with Dr. Pooja ma'am. I think nobody has the query. So Neha ma'am, may I proceed for the next participant? Neha ma'am.
We are sharing your presentation. Please be ready. Sir, Abhay Tade, unmute.
Abhay Tade, okay. Abhay Tade, you may proceed now for your presentation. Abhay Tade. I think we were on the third slide of your presentation, so you start after third slide.
मैम मैंने अभी पीपीटी भेजे, पहले भेजा था नाजिया मैम को, अभी भी भेज दिया है पीपीटी.
Okay. They will run from their side. They will run. They will help you.
ओके मैम, पहले से देना है क्या इंट्रोडक्शन से?
नहीं, we have approached up to the third slide, so you may continue from the third slide.
ओके मैम, ऑब्जेक्टिव्स ऑफ द स्टडी से.
Okay, yes.
मैम आवाज आ रही है मैम?
Yes sir, आपकी आवाज अच्छी तरह से आ रही.
मैम स्लाइड पीपीटी नहीं ओपन हुआ, मैम को भेजा था.
एक सेकेंड, आई विल ओपन.
ओके. Yes, ma'am. Thank you, ma'am. I continue. Objectives of the study.
Yes, sir.
इस स्टडी के 5 मेन ऑब्जेक्टिव है. फर्स्ट, इंडिया में इंटरडिसिप्लिनरी रिसर्च की ग्रोथ को स्टडी करना. सेकंड, मटेरियल साइंस और सस्टेनेबिलिटी के बीच नॉलेज कन्वर्जेंस को स्टैटिस्टिकल टूल से एनालाइज करना। थर्ड, रिसर्च पब्लिकेशन और कोलैबोरेशन के ट्रेंड्स को आइडेंटिफाई करना। यस यस सर। फोर्थ, आवाज आ रही मैम? फोर्थ मेन ऑब्जेक्टिव इज इंटीग्रेटेड रिसर्च का कंट्रीब्यूशन सस्टेनेबल डेवलपमेंट गोल्स की तरफ इवेल्यूट करना। एंड फिफ्थ इंपॉर्टेंट ऑब्जेक्टिव ऑफ द स्टडी, रिसर्चर और पॉलिसी मेकर्स के लिए एविडेंस बेस्ड इंसाइट्स प्रोवाइड करना। सिंपल शब्दों में यह स्टडी यह समझने की कोशिश करती है कि कैसे अलग अलग डिसिप्लिन्स मिलकर सस्टेनेबिलिटी को स्ट्रेंथन कर रही है। रिसर्च मेथोडोलॉजी, यह रिसर्च सेकेंडरी डेटा पर बेस है। डेटा रिसर्च पेपर, इंस्टीट्यूशनल रिपोर्ट्स और पब्लिश सोर्स से कलेक्ट किया गया है। गए हैं फाइंडिंग्स को क्लियर प्रेजेंट करने के लिए ट्रेंड डायग्राम और पाई चार्ट का यूज किया गया है। यह ग्राफिकल रिप्रेजेंटेशन हमारे ग्रोथ और कंट्रीब्यूशन को इजीली समझने में मदद करता है। रिजल्ट, ट्रेंड डायग्राम से एक क्लियर पैटर्न सामने आते हैं। 2015 में इंटरडिसिप्लिनरी कोलैबोरेशन अप्रोक्सीमेटली 10% थी। यह ग्रेजुअली इंक्रीज होते हुए 2022 तक 40% तक पहुंच गई। यह स्टडी अपवर्ड ट्रेंड इंडिकेट करता है कि रिसर्चर अब सिंगल डिसिप्लिन अप्रोच से बाहर निकलकर कोलैबोरेटिव मॉडल एडॉप्ट कर रहे हैं। इसका मतलब है कि नॉलेज कन्वर्जेंस रियल और मेजरेबल है। रिसर्च एरिया कंट्रीब्यूशन, पाई चार्ट हमें बताता है कि कौन से रिसर्च एरियाज नॉलेज कन्वर्जेंस में मेजर कंट्रीब्यूशन दे रहे हैं। इको फ्रेंडली कंस्ट्रक्शन सबसे बड़ा शेयर होल्ड करता है। उसके बाद रिन्यूएबल एनर्जी एप्लीकेशन का सिग्निफिकेंट रोल है। बायोबेस्ड इंडस्ट्रियल मटेरियल्स और वेस्ट मैनेजमेंट भी इंपॉर्टेंट कंट्रीब्यूशन देते हैं। यह क्लियरली शो करते हैं कि सस्टेनेबिलिटी एक मल्टी डायमेंशनल एफर्ट है जिसमें मल्टीपल रिसर्च डोमेन्स इन्वॉल्व है। नेक्स्ट स्लाइड। डिस्कशन, नेक्स्ट स्लाइड प्लीज। ओवरऑल रिजल्ट एक पॉजिटिव डायरेक्शन दिखाते हैं। इंटरडिसिप्लिनरी कोलैबोरेशन स्टेडीली इंक्रीज हो रही है। रिसर्च डाइवर्स और इनोवेशन ओरिएंटेड हो रहा है। इंटीग्रेटेड रिसर्च कॉम्प्लेक्स एनवायरमेंटल चैलेंजेस को एड्रेस करने में ज़्यादा इफेक्टिव है। आज के टाइम में सस्टेनेबिलिटी के इश्यूज को सॉल्व करने के लिए सिर्फ एक डिसिप्लिन काफी नहीं है, इंटीग्रेशन ही सॉल्यूशन है। कंक्लूजन में हम कॉन्फिडेंटली कह सकते हैं कि मटेरियल साइंस और सस्टेनेबिलिटी के बीच नॉलेज कन्वर्जेंस इंडिया में स्टेडीली ग्रो कर रही है। स्टैटिस्टिकल एविडेंस क्लियरली शो करता है कि इंटरडिसिप्लिनरी रिसर्च, इनोवेशन और सस्टेनेबल डेवलपमेंट दोनों को एक ऊंचाई तक लेके जा रहा है, आगे बढ़ा के लेके जा रहा है। यह स्टडी फ्यूचर रिसर्च प्लानिंग और पॉलिसी डिसीजन के लिए वैल्यूएबल डायरेक्शन प्रोवाइड करती है। आज दुनिया को सिर्फ नए मटेरियल्स की जरूरत नहीं है और सिर्फ सस्टेनेबल आइडियाज की भी जरूरत नहीं है। दुनिया को जरूरत है उन दोनों की इंटीग्रेशन की। बिकॉज द फ्यूचर ऑफ सस्टेनेबिलिटी डिपेंड्स नॉट जस्ट ऑन नॉलेज but on the convergence of knowledge. Thank you for your attention. I will be happy to take on. Thank you so much.
Now the
Thank you so
topic
much,
is
ma'am.
open for discussion. Mr.
Yes,
Abhay,
ma'am.
you have to wait for 2 minutes. Mr. Abhay, you have to wait for 2 minutes.
Okay,
Somebody
ma'am.
may ask their query. Okay, now the topic is open for discussion.
Thank you so much, ma'am.
Among the participants, if somebody has the query, you can share and get satisfied from Mr. Abhay.
Next participant, kindly mention your name and send PPT on given mail ID.
Yes, I think the next participant is Meenakshi Vaman Bodhekar. She has joined the
Okay, ma'am.
session.
हेलो
Yes,
मैम,
Meenakshi.
मेरा हो गया क्या मैम?
Yes.
हाँ हाँ सर, आपका हो गया।
ओके, थैंक यू सो मच मैम।
आपका
सभी का
हो
मैं
गया।
आपका धन्यवाद करता हूँ। ओके मैम, थैंक यू सो मच।
It's okay, sir. Meenakshi Vaman Bodhekar. Miss Meenakshi Vaman Bodhekar.
She has left the
Actually,
meeting,
she
ma'am.
was present before 10 minutes. Okay, so Mr. Manoj Chavan from Marathi department. Mr. Manoj Chavan.
No, ma'am. He is not
Raj Kamalji
in the session.
Yes. Asmita Sanjay Dhavas, Arts, Commerce, Science College, Maregaon, Political Science. Miss Asmita Sanjay Dhavas, Arts, Commerce, Science College, Maregaon. Her subject is Political Science.
No, ma'am.
Miss Asmita, have you joined the session?
She has not joined the session.
So, Neha ma'am, the list that you have sent, shared with me, all the participants, their name are over. And I think only 4 participants have delivered their presentation. May I read their name? Archana S. Navle, Mr. Abhay Mahesh Taide, Mr. Actually this Sayyid Samiuddin Sayyid Riazuddin. He has faced the technical issue, and Dr. Pooja Akode. So I would like to request Mr. Sayyid Samiuddin Sayyid Riazuddin, if your technical problem is over, you may proceed for your presentation. Mr. Sayyid Samiuddin Sayyid Riazuddin, have you joined the session?
Mr. Sayyed, kindly reply. Ma'am, serial number 4 is ready. Mr. Kallur Subramanyam Ayadurai.
Kallur Subramanyam. Okay. Yes, Mr. Kallur Subramanyam Ayadurai, Shankarlal Khandelwal, College of Arts, Science and Commerce, Department of Physics. Has he joined the session?
Yes, ma'am.
Yes, and then ask him to proceed.
Sir, kindly unmute yourself.
Mr. Subramaniam, you may proceed now.
Am I audible now?
Yes, sir, you are audible.
Good afternoon to
Yes,
everybody.
yes,
What is the timing given to be duration? 5 minutes or?
Good afternoon.
Good afternoon.
No, you have been provided 10 minutes, 8
10
minutes for presentation and 2 minutes for the interaction.
Okay, I don't have formal slides for presentation. I'm going to only talk about something very unique about the various discoveries in the area of
Yes, sir.
chemistry. Yeah. Am I audible?
Yes, sir.
Sir, nice to see you. Yes, sir.
Thank you. Thanks for the compliments. I'm only going to talk the various methodology and mechanisms we may have to adopt in making the teaching profession, the knowledge imparting profession, the knowledge imparting mechanism interesting and very innovative, so that many people will get inspired. Today, it is a very big challenge to retain, sustain, and maintain the students in their respective faculties. I was very glad to see many people presenting the various discoveries in the areas, leading areas, especially sustainability. Yes, sustaining the students within the curriculum, academic curriculum itself is a big challenge. Then only it is a question of sustaining the various inventions and discoveries. Today with the NEP, people, it is very good, NEP is very good, but the adaptability and the adjustability, the acclimatizability, familiarizing yourself, it becomes a challenge, if not a problem. It is a challenge. So the best point which I would like to tell, that before we talk of any discovery, before we talk of any particular subject, am I audible? Am I audible?
Yes, sir, you are audible.
Before we talk of any particular subject in chemistry, any particular discovery, any particular chapter, it is always advisable and it is very relevant to get into the history behind such discovery. How the people have come out with these sensational speculative discoveries. I'm sorry, I have not come out with any formal structured presentation. I'm only going to give you the various historical account of how people have come out. I will just tell one small example. Michael Faraday, most of you may be aware of this scientist. He is a scientist, he is not a qualified man. He is a school dropout. He was in a small village like Darwa or maybe Pandarkauda in England, you know, very small village. He was a son of an ordinary blacksmith. So Lokandicha Kam Karnara, he is son of a very poor, blacksmith. He was working on steel and all. One fine morning, he was finding some other gentleman studying something. He happened to read those books, and he is a man who is responsible for finding out the sensational magnetism, ferromagnetism, paramagnetism, diamagnetism, and electricity, and all those basic electromagnetic theory. He is the father of that. You all may be aware of Albert Einstein. Every day before leaving his home for the office, scientific laboratory, he used to worship Michael Faraday and then only will go to the laboratory. Such a great scientist. Many people, however small place they may be, they have come up the hard way, and most of the instances, small incidents, have been responsible for their very sensational discoveries. Let's talk about Archimedes. You are all aware, Archimedes, everybody is aware. One day the king called him and gave him a golden crown. He said, how pure it is, I must know. Without destroying the crown, you must tell me the purity. All of you may be aware of the story. The laws of flotation. When a solid is completely immersed into a liquid, the apparent loss of weight experienced by that solid is equivalent to the weight of the... See, these are all the discoveries. This he has found out just by accident. He was taking bath in a tub. Suddenly he found his body weight was equivalent to the weight of water displaced. And then he could make out water density is 1. What is the density? He could find out. The moment you know the density of gold, then you can know the purity. In fact, the amount of water displaced on immersing a golden crown in the water was higher, so he could find out that the density is not the actual density. It was contaminated, or it was, it was having a lot of silver in it. So the goldsmith could be punished by the king because of Archimedes. And it seems the other obscene part of it is he went naked, running around out of the bathtub, and he started crying, shouting, "Eureka, Eureka!" and all. So this is how many sensational discoveries have come. Take, for example, Boyle's law or Charles' law, Gay-Lussac's law. It's a thermodynamic, very important discovery in life. Everyone knows the pressure of a given mass of the gas at constant temperature is inversely proportional to volume. How he has found out? How Boyle's law, how he has found out? That's very important. At constant pressure, at constant temperature, Gay-Lussac's law, Charles' law. And the most important thing is, universal gas constant, or in chemistry, R is very important. It is a very sensational quantification. How did he find out? Actually, most of the scientists who have declared their discoveries could not quantify their discoveries. Another small example I want to give. The teachers should tell the story, because most of the scientists, they are all ordinary students from places like Darwa or, Amravati, Akola only. They are all not from very big towns like Bombay, Pune and all. No, they are all from a very humble, simple beginning in a small, little insignificant village. And then also they could come out with very, very, very interesting speculative discoveries. Take, for example, I would like to quote Avogadro. Avogadro is a very extraordinary scientist, all of you may be aware. He is the first man to declare that equal volumes of all gases under the same condition of temperature and pressure contain the same number of molecules. The most interesting thing is, if you go to the history as to what has prompted Avogadro to give such a prediction, it is beyond imagination. It is beyond understanding of everybody. Why? Because Avogadro has only told equal volumes of all gases, a small gas like hydrogen or helium and a very big gas like xenon or radon, under the same condition of temperature and pressure, contain the same number of molecules. This much he has told, but he has not discovered Avogadro number. It was proved to be correct and later on found by some other scientist. All of you in the chemistry department know what is Avogadro number, 6.023 into 10 to the power 23 moles. See, this discovery was quantified. Avogadro number was not discovered by Avogadro. It was quantified by some other scientist, Emily Clapeyron. And since Avogadro has postulated this theory, this particular hypothesis for the first time, it was named after Avogadro's number. The due credit is given to him. The teachers should go to the history instead of jumping into the subject directly. Because once you broach the subject with the history, because all those historical inventions, unless you include the history of this discovery, the various concepts which they have discovered will not very easily go home. It will be more interesting, it will be more appealing, and people will take more and more interest and get attached, involved, associated with the subject. That is the biggest challenge of the day. It's a very big problem. Nowadays, I think, if I'm not wrong, I'm not supposed to comment on this. The speed with which the admission come to science faculty is slowly thinning down or dimmering. It is our duty to make it more interesting, and it's a big challenge. We should definitely give more focus on the history. I want to give you one more small little example. Max Planck. All of you are aware, Planck's constant. How he has found out Planck's constant? It is a very, very, very important discovery. It is a very, very great turning point in the physics and chemistry science. It's very, very difficult to quantify that. But even after, and for example, even Schrodinger's equation, it was in 1926, 100 years back, he has found out the equation of the behavior of a matter wave. He has discovered the equation. Even after 100 years, people hardly understand much of his theoretical concept. In fact, Max Planck used to say, there is a big story, that if anybody claims that he has understood the quantum mechanics thoroughly, he is lying. He is a man who has quantified Planck's constant, but he himself is unable to believe that there can't be any person who can completely understand quantum mechanics. If anybody tells so, he is lying. That is a statement made by Max Planck. Boltzmann constant, another very important constant, how he has discovered the distribution theory in statistical. When you talk of entropy, I think you can't do it without statistical entropy or thermodynamic entropy. You can't get away or forget Boltzmann constant. Again, philosophically, if I am to conclude, there is a famous statement, a philosophical statement in life: you should never depend on anybody. You should be always independent. This is the general advice given by elders to youngsters. But I'm trying to give another parallel line. You can never live alone in life. You should always live with others, be helpful. The whole world is dependent on each other country. this fact is also correct. Are you trying to say one should not be independent or one should be dependent? What is the correct advice? Both are correct. In science, we say there is a great symmetry in the entire universe. Universe is only symmetry. In fact, in the MSc chemistry, we have got a unit, one chapter full meant for symmetry, point symmetry, line symmetry, plane symmetry. Symmetry is universal. This is a fact of life. It is a fact of life. At the same time, in thermodynamics, what we say, the disorder in us.
Respected sir, I'm very sorry for disturbing you, but we have to follow the rules of the schedule.
Yeah, I'm concluding with one sentence.
I would like to
only one sentence. So the history part of all discovery will have to be equally even important than the discovery matter itself. That would make the subject more interesting, and that would turn the student to turn out in large numbers and stay more focused on the subject. It's a big challenge, but it should be adopted. That's all. With my humble self, thank you for the opportunity of presenting my viewpoint. Thank you very much. Good luck to all of you. Good luck.
Thank you very much, sir. Thank you. Now the topic is open for discussion. If so among the participants somebody has the query, you can get satisfied from Subramaniam sir. If somebody has the query, you can ask to Dr. Subramaniam sir. Neha ma'am.
Yes, ma'am.
Hello, Neha ma'am.
Yes, ma'am.
I think most of the participants that we have gone through the list, they are not present in the panel, online or offline. So I think may I announce that the list of the participants is over. Or if somebody has left by mistake, then he
Yes,
or she has the chance to proceed for the presentation.
There is one announcement for all the participants. If by any mistake any name is left by us, kindly mention your name in the chat box. Or those who have joined the session now. This is the final and the last call for oral and poster presentation. Otherwise, it will be considered as this session is over. So for the technical session, we have been honored by the presence of Dr. Badnakhe ma'am. Thank you so much, ma'am, for your cooperation and for the guidance.
Thank you, ma'am.
Okay. Ma'am, we have got one message. There is one participant.
Yes.
Who is trying to
present. Okay, you may. Yes. What is his or her name?
Yes, ma'am. 1 minute.
I think he is Ramesh Chauhan.
Mr. Ramesh Chauhan.
Mr. Ramesh S. Chauhan, BP Science College, Digras, Department of Chemistry. Have you joined the session? Please raise your hand so that it will be convenient for us. No, he didn't.
Ma'am, there is another participant named Miss Swati Avankar. She is going to present her slides.
But her name is not there in the list.
No, she has responded now. So, with your permission.
Okay. What is her good name?
Miss Swati Avankar.
Yes, definitely. She may proceed. Swati Avankar.
Hello, Miss Swati.
Miss Swati, have you joined the session? Hello, Miss Swati.
Yes, she is there.
Miss Swati, you may proceed now. Share
yes,
your slides with the.
कसं करतो हे करता काय हा येस मॅम
Yes, you may proceed, Miss Swati.
Miss Swati, kindly share your presentation.
येस मॅम येस मॅम मॅडम
Kindly keep the other device
इथूनच करा ना स्क्रीन शेअर करा ना
to
असं
avoid
बोलता येईल थांबा येस मॅम
Mute other side. There is an echo problem.
हे करा
Yes, Miss Swati, you may start your presentation.
हा येस
Miss
मॅम
Swati, share your presentation.
येस
You
मॅम
may
आय एम
share your
ट्राइंग टू
presentation
शेअर
with the chat box also.
Mail the PPT on the given email ID.
Miss Swati, what is the subject?
केमिस्ट्री मॅडम
Okay. Have you shared your PPT with the chat box?
येस मॅम आय एम ट्राइंग टू शेअर माय पीपीटी
If it is possible for you to run the PPT from your own instance.
देयर इज अ नेटवर्क इश्यू
Miss Swati ma'am, your screen is visible, but please share the PPT.
तुमचं पेंटर अटॅच
मेल पे भेज दीजिए PPT.
येस मॅम
Faster.
थोडंसं शेअर करा नाही तर एक मिनिट.
Is there any problem regarding?
Yes, madam.
Kindly send your PPT on the mail or the number of the convener.
Yes, ma'am. Copy करा हे.
There is one short announcement for all the participants that continuing this session, we are going to conduct a valedictory session of today's sessions. So all are requested to kindly remain joined in the session.
नहीं यार.
मेल ॲड्रेसवर पाठवा.
हॅलो हॅलो मॅडम मॅडमच्या नंबरवर पाठवा. मेलवर
Yes.
पाठवा बरं. हेच आहे PPT.
आला का मला पाठवला.
Miss Swati?
Yes, ma'am.
Yes, your PPT is ready. I'm going to share it. Kindly present.
Yes, ma'am. Thank you, ma'am. Good afternoon, everyone present in the conference. Am I audible, madam?
Yes, you are audible.
My name is Swati Uttamrao Avankar. I am from Mungsaji Maharaj College, Dharwa. There is a 2 days international interdisciplinary conference on the material science and knowledge convergence for the sustainable development. My subject is chemistry, and under the chemistry, I have already work on the synthesis of the novel coumarin-based heterocyclic compound, and so my presentation also on that topic: synthesis and characterization of novel coumarin-based heterocycles and evaluation of their biological activities. Yes, next, madam. My topic content are research proposal summary, introduction, research objective, significance of the problem, literature review, research gap expected, expected research outcomes, etc. Now, there is a coumarin is a heterocyclic compound which is a very useful and that is a very advantageous in the pharmaceutical chemistry also. Coumarin is its derivative have been known for its potential biological activities such as antifungal, antibacterial, antimicrobial, anti-inflammatory, anti-cancer, etc. It behaves as an important subunit for the generation of a new biologically active molecules. Considering broad applicability of the coumarin molecules, the present work undertaken for the synthesizing a coumarin-based newly heterocyclic compound. Next, ma'am. There are some objective of my work to prepare a coumarin-based carbohydrazide as a key intermediate in the synthesis of the title compound. The coumarin to develop the suitable method for the synthesis of oxidazole, triazole, and some also heterocyclic compound linked with the coumarin molecules. Incorporating two or more bioactive components may behave as a single multifunctional agent to treat a variety of diseases. So to use that, we can use the microwave assisted reaction to develop the quick and cheaper method for the preparation of the heterocyclic compound linked with the coumarin moiety. Also, to screen for biological properties, synthesize compounds such as antimicrobial, antifungal, and antioxidant activities. Next, ma'am. Significance of the problem. Coumarin itself are reported to possess a broad spectrum of pharmacological activities. Biocidal activities of coumarin ship bases have been well established and contributed to the toxophoric linkage in them. The main idea of the proposed work to design the hybrid molecule which contain the coumarin and the other heterocycles and some new derivatives product synergic biologically active. The present work has a design for the proposed and identifying potential lead components with the enhanced activity. The new synthesized coumarin-based 5-membered rings with the 2 and more heteroatoms are expected to behave as a new compounds. Substituted coumarin-based carbohydrazide is used as a key intermediate in the research work. The potentially useful precursor for the synthesis of the diverse condensed heterocycles. In the proposed work, our interest to design or to develop the single multifunctional agent for the better drug activity and to treat a variety of diseases that may useful the need of the medicinal science and the society also. The desired coumarin derivative were synthesized using both microwave irradiation method as well as the conventional method, and it is well known that the microwave heating offers several advantages over the conventional technique, which is useful or which is leads to the sustainable development also. Next, ma'am. Next, please. This is the research gap about the work, and though lots of the drug with various pharmacological activities are available, but still there is a need to synthesize a more promising multifunctional pharmacological agents that can be used to treat the multi-disease and have a greater activity than the existing drug by incorporating reactive functional groups. Various routes and lots of scope are available for the synthesis of new analogs of existing pharmacological compound. Thus, with the structural variation and the incorporating multifunctional group, it may be possible to have the better activity than the existing drug. Also, the research is the same field work. Field following the green approach is the need of a time to develop the simple, cheaper, and quick method and the cost-effective bioactive moiety, which is also regarding with the sustainable development. Now, this is the work which is divided into number of steps. Next, please. Next, please. This is the scheme of my work. first I will try to synthesize the key intermediate of the compound. Then after the formation of that key intermediate, we will try to synthesize the covalent ship bases, and with the covalent ship bases we will try to synthesize the number of hybrid compound which is linked with the covalent moiety, and the development, also the work of that compound, which is regarding with the various activities which shows by the covalent moiety, and we will try to synthesize and also evaluate that compound on the basis of biological activity of that compound. Next, please. Expected research outcome of the beneficiaries. The present work aims to incorporate 2 or more bioactive units so as to develop a more promising bioactive entity. With this will serve as a guideline for the researchers in coming future to design the new drugs. It is expected that the synthesized compound with a different substituent and the functional group may enhance the drug potential. The newly synthesized drug will be expected to possess a more practical utility and will be useful for the pharmaceutical purpose and the society, and hence we can try to synthesize such a components or the compounds which is linked with the covalent moiety, which are also the multifunctional multi-directional use in the pharmacological as well as in the chemical purpose, and also which is regarding with the sustainable development also. Thank you, madam.
Thank you. Hello.
Yes, Neha ma'am, all the participants are over, I think so, as per the list that is provided by you to me. Okay. If anybody has been left, then we may recall to her or him. You please announce from your side.
Yep.
If anybody from the participant side has been left by our mistake, then ask them to conduct the presentation.
As per the ma'am said, this is the final call for all the participants who have been absent when they were called. So if there is anyone who is interested, kindly reply.
If he or she has been left from the submission or from the presentation criteria, then you may raise your hand.
I think all the participants have done ma'am presentation, those who were interested.
Okay, so thank you very much, Neha ma'am. I would like to say a few words about this today's session.
Please.
Yes, ma'am. May I, with the kind permission of the convener of today's conference, Dr. Nazia ma'am, may I proceed? Nazia ma'am. Yes, Dr. Nazia ma'am, may I proceed?
Yes, ma'am.
Okay. Today, actually, starting from 12:30 on 14th of February, this session was a very nice session that is conducted by your college from your institution. Today, number of young researchers participated in the oral and the poster presentation. The sessions were very interactive, where whatever the number of the students they have participated the presentation, they have presented their presentation in a very intellectual and skillful way. So I think your institution has provided a golden opportunity, a very nice platform for them to share their research ideas before all the participants. Since the beginning of the session, all the participants have tried their best level to present their topics in a very effective way. We must appreciate them all. Definitely in the future, they will be the good scientists as well as the good teachers. All the participants have taken a lot of efforts to make their topic effective. Some of them, they will get the prizes. So I will congratulate to all. And those who did not receive the prizes, again, I would like to congratulate them also. Remember, friends, failures are not the part of the life. Failures are not the part of life. If you don't fail, you won't learn. And if you won't learn, you will never change. So again, try and do your best level. Never give up because today is hard. Tomorrow it will be worse. But the day after tomorrow, there will be the sunshine. The sun that rises, it has to set. The follows, the flowers that blossom, they have to bloom. So the program that we began at 12:30, we have to end up it. So I would like to express my sincere thanks to all the organizing committee, president, vice president, secretary of the institution, principal of college, vice principal of college, convener of this conference, Dr. Nazia ma'am. She has given a very good opportunity to me to work myself as a jury. So I am very much thankful to all of you. Thank you again. Have a good day
Thank
to
you.
all.
Thank you so much, ma'am, for being with us for this session of oral and poster presentation. It was an honor for us. I am very thankful to all the chairpersons of the sessions which are conducted today, all the resource persons, and especially I am grateful to Dr. Badnakhe ma'am, Dr. Raghuvanshi sir, and Dr. Dhole sir for being with us as a jury members. Your guidance and your remarks will always be helpful for us. Thank you. Thank you so much. So we will continue with the valedictory session. So I request all the participants to be with us. We will start the session within 5 minutes. As an organizing committee member, it will be really appreciable if we see the number of participants for the valedictory session also. I congratulate all the participants, those who have presented, and due to some technical issue, 2 to 3 participants failed to present their PPT. So for the valedictory session, I hand over this session to Professor Dhanashri Kothekar. Thank you. Good afternoon. Good afternoon, everyone. We are going to start the valedictory function. A very warm good afternoon, ladies and gentlemen, galaxy of intellectuals, invited guests, faculty members, and all the participants from different prestigious colleges. I, Ms. Dhanashree Kothekar, take this opportunity to welcome each one of you for the valedictory function of this international interdisciplinary conference on material science and knowledge convergence, recent advances for sustainable development, MSKC 2026. Let us first acknowledge among us the presence of our eminent guests. I am glad to invite the chairperson of the valedictory function, Dr. Sunil Chakwe sir, Principal Musaji Maharaj Mahavidyalaya, Darwa. It is indeed our pleasure to have amongst us the former principal of our college, Dr. Vilas Raut sir, as a chief guest of this function. We have with us the vice principal of our college, Dr. Prashant Bageshwar sir. Also, we have with us the head of commerce department, Dr. Dhawale sir, with us. With immense contentment, I welcome all the three juries of our oral and poster presentations, Dr. Badnake ma'am, Dr. Raghuvanshi sir, and Dr. Dhole sir. Dear all, since yesterday, we all are witnessing the conference aimed to disseminate the message in the society that sustainability is no longer a choice, it's a necessity. And from all the magnificent deliberations, we have highlightedly point out that sustainability is no longer about doing less harm, it is about doing more good. Let us welcome our I request Dr. Ruikar ma'am to please welcome our chairperson of today's valedictory function. Please, ma'am. I request Dr. Sawant sir to please welcome Vice Principal of our college, Dr. Prashant Bageshwar sir. I request Dr. Bhagwat sir to please welcome the Head of Commerce Department, Dr. Dhawale sir. Please, sir. Also, we have with us the Head of MCVC Department, Dr. Akre sir. I request Ms. Neha Mahurkar ma'am to please welcome Dr. Akre sir. Thank you, ma'am.
So यहाँ पर आवे लगे बस ये
I request Dr. Nazia Rashidi ma'am, convener of this conference, to please occupy her chair on the dais. Please, ma'am.
I request Dr. Wakude sir to please welcome Dr. Rashid ma'am.
रुकिए सर को आने दीजिए पहले जरा
Just wait for 2 minutes. Our chief guests are arriving.
मुझे आप बड़े का नाम देखिए जरा कहाँ की है कौन से कॉलेज से बस उतने ही लिखा है क्या
Sorry for the interruptions. Welcome back. Our chief guests are here. It is indeed our pleasure to have amongst us the former principal of our college, Dr. Vilas Raut sir, as a chief guest of this function. I request Dr. Prashant Bageshwar sir to please welcome our chief guest, Dr. Vilas Raut sir. Please, sir.
to share our 2 days conference report. First of all, I pay tribute to Sant Gadge Baba and wholeheartedly welcome our chairperson of this valedictory session, our principal, Dr. S.B. Chakwe sir, guest of honor of this valedictory program, Honorable Dr. V.B. Raut, former principal Musaji Maharaj Mahavidyalaya Darwa, convener of this two-day conference, Professor Dr. P.D. Bageshwar, as well as vice principal of our college, respected Dr. Akhre sir, respected Dr. Dhavde sir, all my faculty members present over here, all the online joint participants, delegates, we have started our international conference yesterday on 13th, and this is the second day of our conference. I'm very glad to put here on record that for this conference, we got a very huge response all over the country, as well as from the abroad. Near about 382 participants have registered for this international event, and more than 200 papers we received for the publications. Yesterday, we have inaugurated this two-day international conference with the honorable or gracious hand of our honorable Pro Vice Chancellor, Dr. Mahendra P. Dhore, Pro Vice Chancellor, Sant Gadge Baba, Amravati University, Amravati, in the gracious presence of our honorable President, Mr. Vasant V. Guikhedkar, Secretary Madam, Professor Dr. Sangeeta V. Guikhedkar, Vice President, Vidya Prasarak Mandal Darwa, Mr. Viraj V. Guikhedkar, as well as we have the guest of honor, Professor Dr. V.S. Jamode, Professor Dr. Vilas B. Raut, Professor Dr. Arun Harne, Professor Dr. Ajay Bilad, Professor Dr. Prashant Vighe in our inaugural session. The session was also graced by our resource person and keynote speaker, Dr. Umesh Nakate from Bangalore, Dr. Muhammad Yunus Ansari from USA, Dr. Shivraj B. Sirsad from Nanded, Dr. Madan D. Ambore from Nanded, and today we had the two more sessions that was online, and that was conducted by our resource person, Dr. Tawfiq Ahmed from Europe, Dr. Jnaneshwar Balu from Singapore. I'm very happy to share here that in the first day, we have all the technical sessions. After the inauguration, we had all the technical session that was gracefully conducted by the different session chair, and all the resource person have grabbed the attention of our participants. In these sessions, we had the presentation on different topics. The first keynote speaker of our conference, Dr. Umesh Nakate, has delivered his talk on powering the future with batteries technology. He has stressed on job and market. Our another speaker has stressed on the contrast enhanced high resolution 3-dimensional imaging of the intervertebral disc. Professor Dr. Shivraj B. Sirsad has given the vibrant talk on chemistry and sustainability and has captured the audience very well. Next, to the Dr. Madan D. Ambore has graced the occasion and grabbed the attention of all the participants by his talk on organomagnet and magnetism without metals. Today we had the invited talk on sustainability synthetic strategies for bioactive molecule from design to sustainable chemistry, scalable chemistry. And the second talk was on continuous flow technology for sustainable chemical synthesis. All the sessions were chaired by our eminent personalities from our Amravati University, Amravati. Just before this valedictory, we had the third session, that was the oral and poster presentation. Different participant has presented their PPT in a very well manner. And for this session, we have the jury, Professor Dr. C.D. Badnake, Associate Professor Dr. Manorma, and Professor H.S. Pundrikar, ASC College, Balapur. Professor Dr. Sangram Raghuvanshi, US Chairman Sangadge Baba Amravati University, Amravati, Commerce and Management. Dr. Gopal Dhole from Telara. Now we have reached to our concluding session, that is the valedictory session, and I am very happy to share that we got and we achieved the success of this conference in the form of different presentation as well as interaction of the participant during the invited talk of our resource person. So I think, in my view, the success of any conference is the interaction between the participants and the presenters. So we have achieved the success. Also, we got a very good response in terms of registration as well as in terms of publication of the research paper. So I'm happy that everyone, those who has contributed directly and indirectly for the success of this conference, I would like to I'm very much thankful for them for their contribution, and they all good hearts who have supported me directly, indirectly for the success of this conference. I'm also grateful to all of them. Thank you. With this word, I'll stop here.
Definitely, ma'am. The conference was really a grand success. Thank you so much for highlighting the events of the conference and the success of this conference. Moving forward, let's have the concluding remarks of this conference by our chief guest, Dr. Vilas Raut sir, former principal, Musaji Maharaj Mahavidyalaya, Darwa. Please, sir.
Thank you, sir.
Good afternoon, one and all. Honorable Chairperson of this concluding function, valedictory function, Professor S.B. Chakwe, Principal of this college. The convener of this conference, Professor P.D. Bageshwar, Professor Dr. N.A. Rashidi, and all the heads of the faculties present over here, Professor Dhawde, Professor Akhre sir, and all the present participants present here over. This is a privilege to be present and to be a part of this grand success of this international conference of this college. During this conference, a nice interaction has been done over the subject cited in this conference, and found that a good result will be come out. It is not easy task to organize such an international conference in a remote place like Darwa, but the team principal of this college and his team has taken tireless efforts and commitment to organize this conference and make it grand success. The response obtained from the participants will be unanimous, and it shows the grand success of this conference. I wish the best luck, best wishes, as well as I here declare that I found this conference in 2 days have a grand success, and it will give some positive results to the society. Merits of this conference may be considered, and the sum of conclusion will be drawn out, which will be sent to the respective authority, and some good result come out, and which will help the conference. Such conferences are very important for the research development of the students. It will also found that this conference helps the researchers, new researchers, young researchers to do the research, to move forward doing research over this such a society helping subjects. So I again congratulate the Professor Chakwe, principal of this college, and his team for the grand success of this conference. Thank you.
Thank you so much, sir, for your words of courage and acknowledgement. Now, moving forward, talent and skills are the crops that are nurtured, groomed, and given all possible opportunities to grow and bloom. With this, let's move on the most awaited moment of this conference, that is prize distribution. It is a moment full of joy, a moment about pride and accomplishment, and a moment of celebration. So let's announce the winners of oral presentation in MSKC 2026. Dear all, as we have only oral presentations over here, the juries have decided to announce all the 3 winners from the oral presentation only. So the third winner of the oral presentation is Ms. Swati Avankar from Mumsaji Maharaj College, Darwa. I request our chief guest and all the dignitaries present on the dais to please felicitate Ms. Swati Avankar with the memento and the cash prize. Please, sir.
मोमेंटो दे दीजिए। पोस्टर नहीं थे ना, तो जूरी ने अनाउंस किया।
Heartiest congratulations to Ms. Swati. Thank you so much, sir. The second prize KD College, Badnera. Mr. Abhay had joined online actually. Many congratulations to Mr. Abhay Taide. We'll make arrangement that your memento.
One of the Abhay is taking on your behalf.
We have our colleague naming Abhay the same name. On behalf of you, the Abhay is collecting your memento. Many congratulations to Mr. Abhay Taide. And the most awaited moment is now come. The first prize of this international interdisciplinary conference goes to the only Pooja Akode ma'am from Nagpur University Arts faculty. I congratulate Miss Pooja ma'am very much for her grand accomplishment. We also have one Pooja in our colleague. Miss Pooja ma'am, on your behalf, our colleague Pooja ma'am is collecting your prize and memento. Many hearty congratulations to Miss Pooja Akode ma'am. I, on behalf of Mungsaji Maharaj Mahavidyalaya Darwa, wholeheartedly congratulate to all the winners and also acknowledge the valuable participation of all the participants. Finally, I invite Dr. Chakwe sir, Principal Mungsaji Maharaj Mahavidyalaya Darwa, to deliver the presidential speech. Please, sir.
सर्वांना नमस्कार. 2 दिवसीय आंतरराष्ट्रीय परिषदेच्या समारोपीय सत्रामध्ये आपण पोहोचलेलो आहोत. जवळपास काल सकाळी 10 वाजता उद्घाटन झालं तेव्हापासून तर आज समारोपीय सत्रामध्ये जो विषय आंतरराष्ट्रीय परिषदेकरता आपण घेऊन आलोय तो म्हणजे मटेरियल सायन्स अँड नॉलेज कन्व्हर्जन्स रिसेंट ॲडव्हान्स फॉर सस्टेनेबल डेव्हलपमेंट. एक समाजोभिमुख विषय या परिषदेच्या निमित्ताने मुंगसाजी महाराज महाविद्यालय दारव्हा येथे आपण आंतरराष्ट्रीय परिषद आयोजित केली आणि या 2 दिवसाचं एकूण कार्यपद्धती बघता ही आंतरराष्ट्रीय परिषद एक चांगल्या पद्धतीने यशस्वी झाली असं म्हणायला हरकत नाही. कारण जे रिमार्क कालपासून या परिषदेसंदर्भात विविध तज्ञ डेलिगेट्स आणि विद्यार्थी मित्र यांच्याकडून ऐकायला मिळाले त्या आधारावर ही कॉन्फरन्स यशस्वी झाली हाच त्याचा एक संकेत आहे. ही कॉन्फरन्स यशस्वी करण्यामागे जे या परिषदेकरता असणारे सहभागी प्राध्यापक आहेत त्या सर्व सहभागी प्राध्यापकांचं फार मोठे योगदान आहे, जे प्रादेशिक स्तरावरून किंवा विद्यापीठ स्तरावरून या परिषदेमध्ये सहभागी झालेत. असं असलं तरी या परिषदेला आणखी ज्याला आपण लक्षात ठेवण्यासारखं असं म्हणू अविस्मरणीय असं म्हटलं जातं ते अविस्मरणीय कॉन्फरन्स राहण्याकरिता माझ्या कॉलेजचा स्टाफ हा निश्चितच यासाठी कारणीभूत आहेत. कारण कॉन्फरन्स जरी 2 दिवसाची असली तरी जवळपास माझा संपूर्ण स्टाफ कला वाणिज्य आणि विज्ञान या शाखेमधून जवळपास 1 महिन्यापासून या परिषदेच्या यशस्वीतेकरिता कायम प्रयत्नशील आहे, झटत आहे. आणि त्याचाच परिणाम म्हणून मला आज या ठिकाणी अभिमानाने सांगावं असं वाटतं की ही कॉन्फरन्स या ठिकाणी चांगल्या पद्धतीने यशस्वी झालेली आहे. मुंगसाजी महाराज महाविद्यालय दारव्हा यांच्यातर्फे आयोजित या राष्ट्रीय परिषदेचं जे आयोजन या ठिकाणी केलेलं आहे, या परिषदेचे समन्वयक डॉक्टर प्रशांत बागेश्वर सर, उपप्राचार्य मुंसाजी महाराज महाविद्यालय दारवा, आणि डॉक्टर नाझिया रशिदी, हेड ऑफ केमिस्ट्री डिपार्टमेंट, या दोघांचा मोटो, या दोघांचा एक इन्व्हॉल्वेशन हे सुद्धा या दृष्टिकोनातून महत्वाचं मानले जाते. आणि म्हणूनच खऱ्या अर्थाने ही परिषद यशस्वी झालेली आहे. ही परिषद यशस्वी करण्याकरिता त्यांना विसरता येणार नाही की ज्यांनी आम्हाला यासाठी मोटिवेट केलं आणि ज्यांच्या मार्गदर्शनामध्ये हे कॉन्फरन्स यशस्वी झाली, ते म्हणजे आमच्या संस्थेचे अध्यक्ष आदरणीय श्री वसंतरावजी गुईखेडकर, संस्थेच्या सचिव आदरणीय सौ संगीता मॅडम गुईखेडकर, संस्थेचे उपाध्यक्ष श्री विलास गुईखेडकर, आणि ज्यांच्याकडे संस्थेची धुरा त्यांनी सोपवलेली आहे असे माजी प्राचार्य डॉक्टर विलास राऊत सर, यांचं नाव घेणं या ठिकाणी मला अगदी योग्य वाटेल की ज्यांच्यामुळे या परिषदेला मला आणखी यशस्वी करण्यासाठी त्यांचं मार्गदर्शन मला या ठिकाणी लाभलेलं आहे. सोबतच जे विविध तज्ज्ञ प्राध्यापक मंडळी या परिषदेकरिता राष्ट्रीय आणि आंतरराष्ट्रीय स्तरावरून लाभलेली आहे, त्यांचाही नामोल्लेख करणं माझ्यासाठी आवश्यक आहे. त्याकरिता ज्यांनी या परिषदेकरिता बीज भाषण केलं ते डॉक्टर उमेश तुकाराम नकाते सर, प्युअल्टा टेक्नॉलॉजीज प्रायव्हेट लिमिटेड, यशोदानगर, जागपूर, बेंगलोर. सोबतच डॉक्टर मोहम्मद युनुस अन्सारी, असोसिएट प्रोफेसर, नॉर्थ ईस्ट ओहिओ मेडिकल युनिव्हर्सिटी ओहा, USA. प्रोफेसर शिवराजजी शिरसाट, यशवंत महाविद्यालय, नांदेड. आंतरराष्ट्रीय स्तरावरून तौकीफ अहमद मुजावर, पोस्ट डॉक्टरल असोसिएट, मासार युनिव्हर्सिटी, बर्नो, झेक रिपब्लिक. डॉक्टर आनंद ज्ञानेश्वर बाळू, पोस्ट डॉक्टरल रिसर्च फेलो, नॅशनल युनिव्हर्सिटी, सिंगापूर. या तज्ज्ञ मार्गदर्शकांचे मार्गदर्शन आमच्या सर्व डेलिगेट्सला लाभलेले आहेत, आमच्या विद्यार्थ्यांना लाभलेले आहेत. त्या सर्वांचं या ठिकाणी मी मनपूर्वक स्वागत करतो आणि त्यांना धन्यवाद सुद्धा देतो. तसंच या परिषदेमध्ये पोस्टर प्रेझेंटेशन आणि रिसर्च पेपर आणि ओरल प्रेझेंटेशन या माध्यमातून जे सहभागी प्राध्यापक आणि विद्यार्थी यांनी क्रमांक मिळवलेला आहे, त्यामध्ये पहिल्या क्रमांकामध्ये मिस पूजा आकोडे, नागपूर युनिव्हर्सिटी, नागपूर. आर्ट्स फॅकल्टी मधली ही विद्यार्थिनी आहे, जिचा या ओरल आणि पोस्टर प्रेझेंटेशन मध्ये पहिला क्रमांक आलेला आहे. सेकंड नंबर अभय महेश तायडे, RDIK कॉलेज, बडनेरा. आणि थर्ड आहे मिस स्वाती आवणकर, मुंसाजी महाराज महाविद्यालय, दारवा. या तीनही विद्यार्थ्यांचं मी या ठिकाणी अभिनंदन करतो. आणि परीक्षक म्हणून या स्पर्धेकरिता ज्यांनी काम पाहिलं ते डॉक्टर श्री बडनाके सर, असोसिएट प्रोफेसर डॉक्टर मनोरमा अँड प्रोफेसर SC पुणकर, ANC कॉलेज, बाळापूर. आणि डॉक्टर संग्राम रघुवंशी, BO चेअरमन, संत गाडगेबाबा अमरावती विद्यापीठ, अमरावती, कॉमर्स अँड मॅनेजमेंट. डॉक्टर गोपाल ढोले सर, गोपालराव खेडकर महाविद्यालय, तेलारा. या तीन परीक्षकांचं मी या ठिकाणी मनपूर्वक स्वागत करतो, धन्यवाद देतो आणि त्यांचं अभिनंदन सुद्धा करतो. आणि एकूण हे परिषद यशस्वी करण्याकरिता ज्यांनी प्रत्यक्ष आणि प्रत्यक्ष महाविद्यालयात राहून किंवा महाविद्यालयाच्या बाहेर राहून ज्यांनी सहकार्य केलं, त्या सर्वांचे मनपूर्वक मी आभार मानतो आणि या ठिकाणी मी माझी अध्यक्षीय भाषण संपवतो. थँक्यू.
Thanks a lot, sir, for your kind support for the organization of this conference. We really appreciate your acknowledgement for our efforts. At the last, I would like to recite one famous shloka, Om Sahana Vavatu Sahanau Bhunaktu Sahaviryam Karvavahe Tejasvina Dhitamastu Ma Vidmi Shavahe. May we all work together with great energy. May our study be enlightening. May we not hate each other. Thank you. At the last but not the least, I request Dr. P.H. Bhagwat sir to express the vote of thanks. Please, sir.
Thank you very much, madam. I, P.H. Bhagwat, from Department of Chemistry, we are present to vote of thanks for the validatory function. First of all, I am very much thankful to Dr. V.B. Raut sir, ex-principal of our college, who was present for the 2 days of this conference and guided us for every moment. I am also thankful to Dr. S.B. Chakwe sir, principal of our college, who has also guided us on this conference and given valuable guidance for this conference. The convener of this conference, Dr. P.D. Bageshwar sir, vice principal of our college, I am also thankful to him that he has conducted such a nice conference. I am also thankful to co-convener Dr. Indi Rashidi madam, who is also present here. I am also thankful to Dr. S.C. Chatur sir, head arts department, Dr. K.V. Dhawale sir, head commerce department. I am also thankful to Dr. C.D. Badnake madam, who was a jury member here. I am also thankful to Sangram Raghuvanshi sir, BOS chairman, commerce and management. I am also thankful to Dr. Gopal Dhole sir. I am also thankful to all the participants who are present here for online and offline, who has made this conference a very grand success. By the permission of the chair, I declare that this validatory function is over here. Thank you very much. Hello. Now we are going to share a feedback link to all the participants. Please fill the feedback link positively. Feedback link is given in our chat box.
आम्हाला जेवण द्या का नका देऊ मॅडम
So it's all from 2 days international conference conducted by Muksaji Maharaj Mahavidyalaya Dharwa. So once again, being a convener, I extend my thanks to each and everyone. Thank you very much.
इसके भी डाल दो और इसके भी डाल दो ग्रुप पर
मैडम